Power on.
Yeah.
Oh, well.
When I shorten these wires up, we won't be able to play with this like that. So,
Okay. Next step blue is off now. I turned it down another tenth of a volt.
You sure it's off?
Yeah, it says 0 now.
Okay.
It's not dumping any more energy into the batteries. As cloudy as it is, I'm surprised it's doing anything at all.
Well, no, there's no load on it. Okay, we're going to have to sort this out another way because we can't have secondary cross like this. There's not room for that.
Ryan says, yay, it lives. So far, it hasn't blown up, so it lives. Right now, Sid is moving the, you're moving the secondaries, right?
Yeah, no, I can't for clarity here, so I gotta get that sorted. This is the easy way to do it, but probably not the best way.
You guys did miss the new testing that we, the new test scheme that we're doing now. That's not rolled out to anybody. It allows me to test the FETs before powering it on. Will a customer use that for anything at all?
Diagnostic if necessary.
Oh yeah, they get a hold of you. Sid, it ain't working.
I like using the impact thing, it's so strong. I think I'll strip out the...
Well, this is my weaker battery, so...
Right, it's still Milwaukee. Okay, we have connection there. I guess you can throw power back on it.
It's still kind of the charge
It
out of
does.
it.
Those are some nice caps.
Alright,
So L1,
second
L2
power on
reversed.
test.
No short there. We'll have to, yeah, we got a lot to install. Power on. 54.5 running. Why is it buzzing?
What button?
Transformer.
Or is it chokes?
No. Well, is it? It is this choke. That one's buzzing angry.
I think we need to do 2 chokes rather than
What's our
just
no
one
load?
choke.
1.4.
That's way off.
Ah.
No. Get the.
That one reads low. Does it read high?
No, it reads high.
Let's try this. Still way higher than I want. Yours probably more accurate. This thing here is
I don't
off
know.
a bit.
Wow, it is buzzing.
Or 1 amp. That's higher than I want it to be. But yeah, that one's buzzing angry. Here's say 1.07. Way lower than the competition, we can do better because that one over there runs 0.7. How high
It
can your
is
power
buzzing.
That's buzzing bad. How high can your power supply go? Up to 60?
Yeah.
Crank it up, see what the no load current goes to. Woo, yeah, we don't have enough chokes. It should move like that.
Okay.
If the current, if you turn it down, below down to 50 volts. Okay, so we're not,
5 on amp.
we're at 900 milliamps, so turn it up to 55.
That's 55.
That's 100 milliamps, 80 milliamps higher. You go to 60, and we do what? 1.2. So yeah, we don't have enough chokes on.
Cutting the power. We gotta redo the chokes, right?
We should.
I say 2 chokes, 2 turns, like we do on there, and then 2 turns on 1 choke. 30 strands divided by 3, 2 chokes. There's gonna be a lot of chokes in there if we try to do a choke per 10 strands.
Yeah, I agree with that. What I'm trying to think is if we're better off with is stacking 2 chokes. 1, 2.
Ow. It's already difficult enough as it is to get.
Oh, okay.
That would be a real pain.
Not any harder than 1. Just shrink wrap 2 of them together, and then run the wires to both at the same time. I just don't know if that's going to be more efficient. But keep in mind, we're running a higher current, but this is also more higher magnetizing current core, so much higher efficiency.
That's just gonna throw everything off and decide to go to the core.
Well, so I have to determine if there's a connection between this core and that core, or is it just black chokes?
John Chamberlain says hello.
A big ton AC.
A little cold outside.
Little cold. It's 15 degrees outside this morning.
Yeah.
It's a little hard to start that thing. He wants to see a cold start.
That would be a cool start.
Easier for the systems because the pressures are lower when it's cold.
Oh, really?
Yeah. Worse for an AC is a hot start.
I don't know anything about AC.
Well, the refrigerant pressure is higher. It's directly corresponding temperature. So the hotter it is, the more pressure.
So it won't
on.
hurt it to actually start it.
No. It's not gonna be frozen until you get way down there.
Oh, what temperature does the refrigerant actually freeze?
That's what I said. I think it's way down, sub-zero.
Okay.
Way down. I don't exactly know because you got 134A.
I assume. Whatever's in the past year, two.
Yeah, the most common is 134. Freezing point is negative 213 Fahrenheit at sea level.
Well, we got a little ways to go before it freezes then.
A little ways.
So it's still in a gaseous state out there.
It boils. R134A boils at minus 14 Fahrenheit.
Nice.
And so it boils.
That's why it vaporizes as soon as it hits the air, right?
Yeah. So it boils at minus 15, but the freezing point is minus 96C, minus 60 Fahrenheit. UNC's popularity weighing with the new 1234Y up, which is stupid expensive and absolute mess. Oh well. We're all going to dig into these ferrets. And MOSFET and primary begin. See if we can get that back down to the 0.6, the 0.7.
You're off.
That's off.
You're good.
We're at 11 o'clock, so I'm going to pull out the time. I guess I better get started.
Yeah, I mean,
Sitting here talking about it's not going to make anything happen.
it fires up, it runs. Just those chokes are really loud.
Well, the chokes are allowed. That also means we're getting more stress on the fits because it's getting a lot more splash from the transformer, which is half resistance. So that's not. I don't want to hand to it.
Oh, come on, Steve.
I grab the
Battery
terminal
power
out.
tools. Nothing wrong with that.
I strip that terminal out. I'll have to get you with your fancy Milwaukee iron to replace it. I know my Chinese cheapo can do it.
Yeah.
I don't think Milwaukee can. Okay.
Wow. Yeah, it's tight in there. Isn't it?
Very tight, yeah. So I'm going to move that back so you have more clearance in there. Are we learning?
Who designed that? There's about looks like about a 10-second delay or so.
Yeah.
Yeah. And it's got to stream all the way to the server, and then it's got to be processed by the server, and then it's going to be streamed back. So, yeah.
About fair.
Yeah.
My observation is the faster computers get, the slower programmers get. The more processing power. Oh, we can add more clutter to it. And boy, do they.
Oh, yeah.
So I guess we're going to do ends here.
So,
Do what?
so I put choke.
You got two chokes on. That's only 10 strands
chokes,
each.
2 turns.
Yeah, that's only. But that's only 10 strands each.
Yeah.
That's a split 15-15, but that's to go on before the crimp, which isn't going to happen, I don't think.
No.
We can try to find.
We
bigger
can do
chokes.
3 chokes per a 6. Well,
I really don't want
24 volt inverter. Yeah.
It's gonna be a mess.
Or we can just find bigger chunks.
Probably a better choice because the materials what makes the frequency.
How do you even search for something like that?
Just a ferret core. You gotta get a big one. But actually, ask the factory if they have a bigger, or ask their supplier for a bigger core because a bigger core will have a higher magnetic range. You can handle more energy, and that would actually help us with no load and higher voltage. That'd be a double benefit. That's one let's stop part. The DGT, prepare for a sticker shock.
Fairly cool.
I know that people say that different ferrites are different effectiveness, and they're absolutely right. I just don't know that enough about them to say I want this type and this core and this magnetic. I just don't know that stuff.
Does PowerTech even know what they use?
Nope. Something cheap. So I'll probably say 1 amp is better than the competition. I don't want to settle for that one. I know we can do better. Oh, those are tiny, way too tiny.
Yeah.
I don't like the E-cores, because unless the thing is, how big is it? Probably about the size of a ring. 15 millimeters inside. Yeah, that thing's tiny. These are 20 some. You have a bunch of them laying around there somewhere.
Look over your head. No,
Here.
it's hot boxes. Got a box of them.
Right here.
There you go.
So these are
Oh, you're looking.
actually 27 millimeters inside diameter. So you got to find something about 40. Is 40 gonna be enough? No, it might be bigger than that.
50?
Yeah, let me start. 50. Doesn't know there, that's the wrong size out. I wonder if it doesn't fit right. This is a little bit challenging.
You designed it.
Yeah. Well, I'm putting it together, I can make it as hard as I want, right?
Oh, yeah.
I'll just hear about it for the next 10 years.
Uh-huh.
Okay, they're out. You know, I'm at it, let's uncross them, because that was a bad decision. Here's the one side, here's the other side.
There we go. 50 millimeter toroid core, ferret, 2 inches, high something or other.
High B set, that's nice. Fair for the 3C8559, I have no idea what that's supposed to be. Well, is that dimensions? So 50 millimeters, 9 by 18 tall. 9 is the diameter, or the thickness of it. 50 is inside or outside? 18 on somebody's thickness. These right here are 15.
59, 18.
So assuming 18 is depth, this one's 15. We have 50 millimeters, that's inside or outside, and the outside, that's about what this is at.
2 inch ferret toroid.
Outside diameter is 50. We need inside the 50.
The inner diameter is 32. Yeah, that's
The inner of this right here is 27.
OG.
Yeah. We need a much bigger core. We don't want to beast out all the other stuff. If someone knows how to calculate that stuff or what's best for this application, let us know.
Talk-
I don't.
Call Sid.
Don't give him my number. I'll never get any work done again, ever. And of course, you know what this means. We'll undo this right here that I have,
Oh, yeah, go ahead.
that I forced in there yesterday.
Everybody
before we
watch
get done.
Sid try to undo his work. Whoa, this thing's huge. Whoa. Whoa, that's
80
almost
by-
too big.
80 by, it's got the 50 inside. So,
How are we gonna fit that in the inverter?
so Spirit toroids, that looks about right. $30 a piece too, yeah?
Somebody's got to be able to get a hold of those cheaper. This is stateside. No, it's
No,
not.
it's from
This
China.
is China. Ugh.
But, I mean,
I'll have to get a hold of Hannah and see if she can get us one of these or a couple.
well, this is what it comes down to, is it, if it's significantly,
wow, that's big.
if it's significantly cheaper to use this right here, then it may be what we have to just use multiple of these.
Yeah, that's fine.
Okay.
$30.
Yeah. 80 millimeters down. Oh, yeah, that thing's, yeah, it is big.
Wow.
I don't think we need it that big, because it's 50 in the center and 20 millimeters thick. This one right here is 10. So it's that's a huge, well, how deep is it? Height 20. So it's 5 millimeters thicker. Yeah, that one's kind of big. What was your suggestion to try on the chokes?
We can either do 10 strands each, or we can do 20 strands and then 10 strands.
I think what that would do to those inductance.
I
I want it to be balanced.
If you want it to be balanced, then 10 strands each.
Requires chokes though. Which actually,
Well,
if we can get 20 strands through one choke, that would work for 24 volt. Boy, I'm heating up in here because I'm about the heater in.
I was just looking to see if they had anything else, but it looks like this is the only ferret.
The only one, well, that's the seller, yeah. Most of the Chinese sellers say, if you need something else, ask. It takes too much time to put it on the store.
How do you sell something that's not in the store?
Contact us and ask. That's my bugaboo with LCSC, where I get a lot of parts from. They have a huge stock of parts, but their parametric searches are abysmally horrible, and so you can't find similar parts that do what you want. You have to know the part number and say, oh, they do stock that one too. How about that? They got a good price on it. Okay, those are out. Let's cross them forwards. So I got the secondaries right. That one's over there. This one's over. Okay. Right there, this one went over. So if this one goes right there, this one goes over there. It's going to be way shorter if I do it right. Way shorter on the secondaries. This I gotta pull out. Plenty warm in here, like an aluminum transformer. one side, that's the junction.
Yeah, it's expensive. 65 millimeter diameter, coal diameter. That is
What's the
20
inside?
bucks.
What's the DigiKey? They're expensive for
I don't
everything.
know. It doesn't say. I have to look at the data.
Okay,
sheet. I just
38.
38.
So it's a little bit bigger.
Might just have to go with what they're already using.
Well, the question is whether I can get 2 full turns.
If you want it balanced, shouldn't you do three then? See if that works. I mean, you can take that transformer home and experiment with different turns if you want.
Oh yeah, easy. But
I don't think it'll hurt in testing to have 2 full turns times 3.
we can try for testing and then we have to compare apples to apples without breaking stuff. It's a lot easier to do it that way. 1, 2, and 3. Me, money, and Mo, right?
Yeah.
Yeah, copyright collectors saying that these days.
Well, at least you don't get flagged for singing the happy birthday song anymore.
You don't?
No, because some judge overrode.
Yeah, it's
Okay.
it's part of American culture by this point. What are you gonna do? What are you gonna do? Can't say that. Oh, where the copyright stuff on that one is kind of funny.
Let's see if anybody said anything. Yeah, nobody's awake. Carlos, are the chokes large enough to fit larger diameter primary wires?
Well, evidently not.
No.
And getting 2 full turns to this right here is gonna be a doozy of a struggle. We're just a single one. So I mean, this is where a huge 80 millimeter core like that, if I'm certain they're jacking the price up because they can. If a huge core like that, we'd only need 2. Regardless of the voltage. So anything going to the MOS boards, you wrap it around. So they'd actually ship it without any ferrets on it. And you would put the 2 ferrets. Anything coming from one goes through 2 turns, another 2 turns. If it's big enough, you get 6 strands in it times 2. It's gonna be hard to do, but
You like that heat shrink on there?
I don't mind it at all. I'm not going to complain. So
Just seems to make a mess for the.
I was actually thinking of then heat shrinking all 30 strands together, but then we'd have a mess unless we had bigger conductors, or bigger ferrets. So. Because I was worried it'd be hard to figure out which group of wires is what, but so far it's not been that bad.
We've only got 11 people watching.
Only 11? What's the most you ever seen? 30?
We saw a good 30, 35 yesterday. Let's see. Carlos asks, how many turns are needed on the chokes? Would 2 turns be enough? That's what we thought we figured out. Two was more than enough because 3 didn't make any difference.
So yeah, I don't know at what point these chokes will saturate. The thing is, you only notice the more turns at higher voltages. So if we're saying 48 volt inverter, if you do 1 turn each, it works fine at 48 volts. But if you take it to 60 volts, the current starts doing that. And you put 2 chokes on it, it goes flat. And then much higher, it starts going down. So,
Yeah, we still don't know if we're doing 60 right now though.
well, I'm saying 60 volts into a 48.
Oh, okay. Yeah.
60 volts should be possible, but it's one of those things, the math says yes, but reality could say no. So, all I have to do with that FET driving, which is, I'll say it, rocket science. You can see the rocket ships over there that didn't make it to the moon.
Yeah.
This will be, the problem with the display is right here, so we can't have this big old bundle right here.
Yeah, that's true. Holy
I
moly.
can't put the display straight over here because that relay's too tall. I don't want to offset because then we look dunky, or look like a robot actually. We could offset if we have to. I mean, we're not making something that goes on someone's living room wall unless they're,
But then my sticker won't run up.
you know it. You know it's going to happen. If someone wants to complain, they're going to complain. That's just the way it goes.
I mean,
There's reasonable complaints, and then there's, it's not the
Can
right
you
shade
get-
of stainless.
can you get them to get those primaries more out of the way?
What do you mean?
Well,
I've told them to make them close as possible.
Oh,
We
okay.
go sideways, but they're coming straight out the side or straight in the fans. They want to have us, they come, all the cranks come here, and these other wires come all the way up here, all the way around Curly 200. That's why I put them in the front. They don't need to go all the way to the back side. But we can space them out a little further. However, I don't have that much control over where they are. Remember, it's a Chinese guy sitting in the machine, putting it on by hand.
Stupid American. What are they thinking?
This will not fit. I tell them, well, you did that and it fit, so my idea definitely will fit. I showed them the math for how it's going to fit. Mine's actually better.
There's no big comments.
Okay.
There's 9 people watching.
You ask me if the chalks are big enough?
Yeah.
I have to say, spelling one of my pet peeves. Okay, let's get this through. I'll run it over the top. So if I do it right, these right here can be much shorter. I'm going to have to lose them here and there.
Wow.
Wow, what?
It's just really, it's a spaghetti mess in there.
And someone's going to say, where's the 12 or the 24,000 watt inverter at 12 volt? So
Keep an eye on PowerJack's catalog.
They already got the 30.
They did, though, drop 24 volts for anything higher than 9,000 watts.
I don't see why, because it seems to me the lower voltages are easier to work with.
So,
From a vent driving standpoint here,
you know what the transformer's insane? One big paperweight.
we've got a lot of papers to hold down. Paperweight and a boat anchor. Okay. Try this on the other side. 3 ferrets.
This is crazy.
Yeah. Somebody said we want a 12K. We gotta have something bigger. I said, well, it is.
It's just, man. I'm imagining myself. I mean, as long as you space that main board out there, I think that's enough considerably. But just imagining me standing there doing this for every single inverter that goes
Yeah.
out.
Looking forward?
It's way easier on the 6K.
Yeah. This is.
I was hoping to, take some load off, not add load.
Reality is reality. I mean, we're not making the whole thing. If we were, that's making the cases.
Just got to make it
People
easy
work.
enough so that it's not a struggle to wind chokes, unless we had the
This
factory do it
this
for
isn't a
us.
struggle?
So, what would be wrong with them doing it in a 48 volt setup on the chokes, and then if I have to make a 36 or 24, then I can modify it. 90% of our orders are 48 volts, so for 90% of them, I wouldn't have to really mess with them.
It's up to you if we can count on them doing the chokes right, but I don't think they've done it right on one order yet.
They would have to label it, and then they would have to choke it.
No, they can
and then-
test it. They can make sure the transformer works with one of their things. It's not hard.
No,
to
it's
do
not
that.
the transformer working. They would, once they've done the testing, they've got the labels, then you could say to them, okay, P123 strand whatever,
Looks like
choke.
Looks like they put this through the choke before they crimped it, so we can do a 15-15. My thing is, on every one of these inverters, this is one you haven't done, that's the first one. Every one of them, they get the chokes wrong, every time. We only have a single turn. This one might have 2 turns. But they've always been a single turn, I specify 2 every time. So,
It depends. If it's the new fat ones that they fixed, I can't get 2 turns through there, no matter how hard I try.
well, I'm saying
One
you
is
can-
all I get.
I'm saying you can't, I'm saying I tell them 2 turns. They
Right.
always just do 1, regardless. So you have
Well,
to take
they're gonna
everyone
have,
out.
I mean, I guess.
Take everyone out and put a second turn on it. They're here at James. Yeah, they put this ferret on before they put the ends on.
Well, that's just fancy.
Yeah, it is. And
Let me guess, it's not gonna unwind itself.
not very nicely because they're twisted inside and out of each other.
Can you cut the ferret?
Don't want to because it's
Yeah.
conductive. We spray that metal dust and everything, turn off and blow up. Yeah,
Why
it's
did they
not
do that? Why?
easier?
I UPS.
Didn't tell them not to.
So you're gonna have to make a list of don't do this and then a list of do this. Otherwise they'll do that you don't want them to do. Your brother wants to know why it's easier on the 6K.
What's easier than 6K?
I'm assuming the chokes is what he's talking about.
About 1/3 the wires. $6K smaller diameter wires.
It doesn't take me hardly anything to add chokes to the.
Well, yeah, you want a single 10
Yeah.
strand. This is 30. So the 6K should have the same diameter wires as this. The smaller one was actually my group. I'll go back to my spec manual and I specified the smaller wire. I'm like, oops.
It's his fault.
Can't blame Power Jack for that one because they did what I asked for once.
I know. You guys messed up. You did what he wanted. Oh.
It's funny, they always tell me it can't be done. They keep doing what can't be done. This will not fit, it's too small. Okay, then use this instead. You wanna help pull this out, Sean? Get a taste of a 12K?
What are you? Oh, no way.
I'm still trying to get this second one on.
No, this is your fault.
I didn't put this one on.
You
I put that one on.
No. See, now you're gonna feel my pain,
Huh?
and you're gonna be like, I'm gonna make this easier on him.
Maybe until Christmas.
I mean, he did fix our oven. You broke half of it, fixed the other half.
Well, the window broke the whole thing.
Yeah.
And the penguin fixed part of it, but took too big of a bite out of something else. So instead of no ovens, you have one now.
Half worse, half better.
It's not, well, yeah, whatever. But you can fix the other half. Find some conductive glue to put that membrane back together again.
Yeah. So for those who are watching, Sid's struggling with these chokes. Now he's figuring out the struggle is real. And I don't want to have to do this on every single unit that's going out. So we'll have to make sure they get it right. Man.
Well, that's why we use a bigger choke. Just have two big chokes.
If they can find them though, that's the
They
problem. I
can
don't
find
like-
them. If you find on Alibaba or eBay for purchase in China, you can find it. And if not, they order
Yeah, but
the
how can we verify that it actually works though? They could call it something and it's sand or something inside of it.
There it is, sand.
Well, I mean, it's not. You know what I mean? It's a ripoff. It can be made out of nothing.
Yeah.
That's
why.
the problem.
So that's what I haven't had issues on Alibaba, but I always go for the manufacturers. I'm not the people that get scammed off all the time.
Yeah.
They're trying to find the cheapest price on counterfeit goods, and you're going to get ripped off. That's just going to happen. But for example, when I'm one of these relays here, I go to a relay supplier. All they make is relays. Now they do rebrands of chips, and for the bus bars, all they make is bus bars. And so when you do that, you're going to get genuine products. If you get a reseller, they'll sell you whatever they can, whatever's off the shelf. So, someone tells you they got free batteries?
No, I've been asking for product specifications on their batteries so that I can compare sizes.
Yeah.
They're telling me that it's a 400 amp cell and it's the same size as a 280. Well, that's obviously a ripoff.
Well, you know what that is. It's a rebranded 280. No, it's a rebranded 400 that's worn out.
But I don't want a worn out cell, even if it is 280.
Yeah, well, if it's the same size as 400, it's worn out. You don't want it.
That's exactly right. So, these 280 cells that she is selling right now, let's see. Height? What? Oh, that's H. Yeah, height. 207 millimeters. That's right on par with the other ones, between 200 and 210. So that's definitely not a bigger cell that's been worn down.
You have to calculate.
This is the one that a couple people were pushing me on with this Amy lady, because she's got 280 cells that are apparently genuine and are very cheap.
Okay.
The guy that Ray, whatever his name is, that's on YouTube.
Okay.
He apparently he bought these exact ones. He bought what was it, 300-400 of these cells. It was
Yeah.
a It was an ungodly amount of cells. I don't know what he's using it for.
Gotta laugh, it's kind of funny. One of the people on the forums bought 500 or so of these things.
Mm-hmm.
Just trying to run on a power jack and saying, come on, how much money you spend on batteries again? You bought a power jack?
Then there's this other company that I'm looking at that has a similar price, but they're 500 amp cells.
Okay.
So that right there is a flag. These are the 500
Well,
amp
it's different.
cells.
If it's a different,
Right, but it's a similar price. 120. If I were to order,
well, it says 400, 500.
yeah, but it's $108 for the other cells. So you're
Yeah.
looking at an extra $10 a cell for almost twice as much. Something
Something
doesn't add
sounds a
up.
little fishy there.
So, that's why I'm looking at all this stuff and trying to, like what you did, make a chart that shows, okay, this is not genuine, this is genuine, or,
I mean, at the end of the day,
her name is Fancy.
oh, they love their American
Fancy
names.
Lee. She did not send me a spec sheet on these. She just asked me how many I wanted. I wanted a spec sheet.
How many do I want? One spec sheet? Thank you very much.
500 amp hour, 3.2 volts. Maximum price 125 per cell.
Well, those prices don't
Here.
mean anything.
Okay, well, yeah. If this is correct, 385 millimeters tall, 80 millimeters wide, which is considerably bigger than those 280s.
80?
80 wide.
I'm not sure on that one.
Let's go back and look at the. What's T? Oh, 72 millimeters on the 280 cells. Height 207. So slightly wider, but almost twice the height.
So if you do a chart, you just have to take the, was it volumetric square? Multiply all three, get the cube of it, and then you can see easily differences beyond just dimensions. It's really obvious.
Because if I can go with fewer cells but the same amp hours, that's cheaper because these 500 amp hour cells are cheaper per cell
Yeah.
shipped than the 280s. But if they're garbage because they came out of a bus or something like that, another issue. But if they're this big, you'd think that they would be. This is what I don't like. It's like I feel like I'm gonna get ripped off no matter how I look at it. Like, if they find out that I'm going to YouTube with it, they're going to send me the best cells that they've got. And then when I go to order the next set, confident that the next set is great, they'll be garbage. You know what I mean?
Yeah.
So it's like, I almost shouldn't, I haven't been mentioned. I'm going right to YouTube with these, test these. I'm like, I need to order 16 so that I can test them. So once I say I need to order 16 and test, they're like, okay, prioritize the newest cells to this guy, because he's going to test them first. Then when he orders another 200 cells, send him the garbage. You know what I mean?
Well, see, it's not just China does that. I know someone who worked at a popcorn company,
Yeah.
and they got a request for a sample shipment.
Mm-hmm.
They bought a machine that checked the color of each kernel of popcorn, rejected all the ones that were wrong, kept the good ones. They spent a month getting enough good kernels to fill one semi. And every day they're saying 5 semis out of all the junk. So
Wow.
the sample semi, they bought a special machine to make sure everything was just perfect. They're saying 5 semis a day. It took them 1 month to do or something like that. They're like, it's not just China. America's done it too. We're not innocent across the board.
It just seems like it's a little bit easier to get your money back here in the States. You could do a
You sue
charge back.
Everybody does a sue them.
Yeah, that too. Yeah, I don't know what kind of guarantees Alibaba has. If you send them 40 grand, what are your guarantees?
So
And they all say, because I say, well, what if I have a bad cell and they don't perform? Oh, we replace cell. Well, okay. You're supposed to go through 200 cells and check each and every one of them bring them all the way down to 0 and verify that they do have the amperage that you're, I don't know, it seems like a complicated mess.
Okay.
Let's see what the live streams is saying. Somebody's gonna say something.
Nothing yet?
No.
Yeah, people say this transformer is insane.
Okay, yeah, the guy that's in Texas is actually the Amy person. She's got cells in Texas. It's the similar. They've got a warehouse in Texas that they ship these from because they offered me to send me for an extra $500.
Mhm.
I would get them in 3 days, basically.
Yeah,
You're still paying for the freight across the sea, but you get them a lot faster.
yeah.
And they have a warehouse in China and California.
They definitely put the terminal on this. They're all jumbled together down here.
Yeah. I've got that problem sometimes on those. They will do that on those, and that's really annoying. And I just leave the choke where it's at. Because I take the chokes off when they're going to the interconnects.
Yeah. They really
It's
don't.
a waste.
Yeah, it is.
It doesn't do anything. So, but sometimes it'll be all twisted up, and I'm like, oh, forget this. I'm just leaving the choke where it's at. Who cares?
I don't hurt anything.
Yeah.
How far down do I want these to be? Go down there on the transformer.
All right. See who else messaged me. 4 messages from Anna.
Anna.
Dear friend, the shipping fee is $1,090 for what? For 16 units, $1,090. 2 custom clearances and tax. Transport by sea. Special line. 2-door time is 28 to 30 working days.
Yeah?
$1,090 for 16 cells that are 500 amp hours.
Yeah?
500 amp hours. What's that? Okay, so 125 per unit.
DDP. So they got the DDP. That's important because you gotta know what these terms are.
Oh, what's that term? Say
Delivered duty paid.
okay.
So it's Incoterms. And actually, I started out with Alibaba. I was trying to figure out what Incoterms meant. I pulled a chart up, and
25.
they want to do FOB, which is freight on board. And that basically means if you sign a contract on Alibaba to purchase, and they have the terms as FOB, if it's stuck on a dock in China,
Mhm.
when they push it on that dock, it's your responsibility to get a trucking company in China to their dock to pick it up, do all the paperwork, to get it to the boat, get it in there, get it across the boat. So they do nothing. And so I refuse to pay an order that they're shipping to me if they have the terms as FOB. They say, oh, we send it express, it'll be fine. I said, no. That order needs to say at least DAP, delivered at place, or something like that. Unless I have a shipping company and I'm responsible for dealing with all that. Otherwise, I have no legal recourse.
Hours worth of cells, 48 volts.
You said $3,000?
$3,090 is the total.
$3,090. Okay?
That's 500 amp hours, 16 cells.
500 times 51.2, that's 25.6 kilowatt hours. So 3,090 divided by 25.6, that's $120 a kilowatt hour. That's not bad. That's what I got mine for. I got a heap of elbow grease in mine. That gives you 25 kilowatt hours per block. Assuming they're 500 amp hours.
That's more than I've got right now on,
2 power walls.
yeah. 189 a piece on those, minus 10%.
Minus 10%, what do you mean?
From battery hookup. They tested them to 90%.
Oh, okay. So you got used cells there.
Yes, they're used. They were they called them in backup systems, so they stayed in float most of the time. Okay, well see, here's another problem that I have. These cells seem to be pretty rare, so I'm worried that if I order a bunch now, I mean I'm not going to today obviously, but let's say I order a bunch and then in 2 or 3 months I'm going to order a bunch more. Oh, sorry sir, we don't make those anymore.
All the same chemistry. That makes a little beans of difference.
You're sure about that?
Absolutely.
So I could mix 280s and 500s and it would not degrade or bring down or increase resistance or anything else like that. I'm not going to know the difference.
Correct.
What about the charge controller itself? That doesn't care either?
Nope.
Hmm.
Nope. Absolutely no issue.
I might go with Anna then.
So the only issue is when you're mixing different battery chemistries. So that's what they were saying last night in the live stream, mixing lithium iron phosphate and lead acid. That's not good. You can mix lithium iron phosphate and lithium ion, sort of.
I wouldn't.
I mean, I wouldn't myself. You have to have separate balancers because of different voltages,
Yeah.
but I wouldn't. You could. Because the lead acid drags things down. That's why lead acid you have to have about the same age, or they'll always pull down the lowest cell. Okay.
28 to 30 working days.
Yep.
DDP means right to the door, right?
Delivered, duty paid. So they are responsible for the fees and everything all the way to your door. Now, of course, they're responsible. You pay the fees.
What? Yeah.
They're responsible, and they have to do all the paperwork. So actually, if you look up Incoterms, see if Windows knows how to do this. Oh, it's a tangent. Windows doesn't know how to do
We're in
it.
Chrome. Incognito.
Incoterms. There we go. This right here, one of these. So this shows you, get the thing bigger already. Oh, Windows doesn't do that. Windows doesn't do that.
Sorry, sir. This is the better operating system.
No, I'm trying to zoom in. Windows doesn't know how to do that. So you can't, it's microprinting data classes. So, EXW, FCA, FAB, FOB. So the seller does this, and the buyer is responsible for this. So DDP, the buyer is responsible for unloading destination, which if it's shipped to your door, you have to get it off the dock. It's a big deal.
Oh yeah.
If you get yeah, so this right here, DPU, delivered at place, there's something else I can't read, is the buyer is responsible for import duty, taxes, and customs clearances. But if you do FOB, you're responsible for freight charges, insurance, terminal handling, delivery destination, unloading, all that. Freight charges. Loading on carriage is FAS. I mean, they can really do nothing if they want to.
30 days. So 30 days from the time I order should be at my door, according to her.
That's boat. So 30 days boat time. But then you have to deal with
No, she
shipping
says
company.
to door time is 28 to 30 working days.
Okay, well, that's good then.
Transport by sea special line. That's what we gotta transport the
Last.
inverters with. Sea special line.
They work better. I'm quicker.
It's a jet boat.
Jet boat of the seas.
Okay, well that's something to consider. I wonder, okay, if I were to order 160 units, it's 115 per unit, but I don't know about shipping. Does shipping get more expensive the more you order per battery?
It
Or
shouldn't. But remember, the shipping containers are, the prices have gone through the roof on those. So
Yeah.
simple economic supply and demand, though. You have a bazillion people ordered Xboxes on their couch. Takes a bit of shipping space to use that.
Mhm.
So the price goes up. Okay, let's see if I can get two more squeezed in here, make this look a lot better. Get an idea for how it's supposed to look when it's fully assembled.
Well, that is a lot of, that's a lot of work there to set those chokes. If we can get them to set it for 48 volts, just the chokes, not the terminals, obviously, that would save me a considerable amount of time, because 99% of our orders are gonna be 48 volts.
Just the strange people want 24 volt.
Yeah, if I have to spend a little extra time on that, then that's fine, but the 48 volt customers, I can get out the door much, much faster.
Here I was all worried about 200 amps. 200 amps to start a car, that's a lot of power. That continuous on this, 600. Oh my, I thought you could only use relays to do that. Nope, we got FETs. Switching that.
Alright, so,
Like Jack says, FETs really are magic. Doing all this control and power and silently with no moving parts.
Carlos says, get the batteries from a US distributor, more protection on your part. Yes, but more expensive as well. So, kinda gotta weigh the cost there. Your 12 kilowatt model, what is its max inrush current on 240 volts? Or how high can you set your current limiter in amps at 240 to start a 3 horsepower motor? I need approximately 115 amps of inrush current.
at 240 volts. That shouldn't be a problem. 115, because that's just over double the rating at 48 volts. Now there's someone asking me about starting a giant motor like that on 24 volts, and that's not gonna be possible.
Oh yeah, they don't say what their battery voltage is.
Yeah, that's critical, because the enemy of everything is amps, and if you go to lower voltage, you increase your amps. And so yes, it should be able to do. Thing is, the FETs are rated. The whole batch, if you work it perfectly, can handle 1100 amps on FETs. At 48 volt,
Total?
yeah, 1100
Per MOSFET?
total board is what I would say. It might be able to do more
AC?
DC. DC battery current, 1100 amps.
How many amps is, or how many?
So 48 volt continuous is right around 300. We have almost four times range for surge. You go 24 volt continuous, 12 kilowatts is 600 amps. We have less than double.
Before you have to, are you gonna adjust that so that if it's a 24 volt
Doesn't
inverter?
matter. The current limit stays the same as the FETs are the same. So
Okay.
the current is going to be the same limit regardless of voltage. It's going to be
Alright,
the same
well,
level.
good.
So
Well,
that's
we're
not-
gonna have to make that clear in our manual that if you order 24 volt, you're getting half the surge.
Yep. There's no way around that. So when people say, look at the MOSFET data sheet, it says you can do 540 amps pulse. Well, that's 300 microseconds, and these surges take 2 seconds, and they're not going to survive.
Same chemistry, yeah, they're just talking about
Yep.
batteries. What you already said, basically.
Lithium ion has highest density. If you want true density, get lithium polymer. I don't recommend it one bit because it's extremely dangerous, but boy, do you get density.
I'd like to have this house not burn down, so
Preferably, you know.
yeah.
So I don't want polymer batteries myself because they're very high density but very dangerous.
So did you manage to get it?
Yeah, they're all bolted back
Wow.
on.
It'll be a little bit easier when you move the main board up a little bit.
40 millimeters this way, we're up a
Yeah.
lot of space. So
Is the rubber pad still intact there? Still good?
yep, I need to hook the second L2 back up. Look over the top, over out here. Hopefully we don't get transform polarity error this time.
So the bus bar company can easily make us one that's a little bit shorter, right?
Oh, yeah.
40 millimeters, you said?
I'll have to redo the math on it all because I got the math right on the bus bar.
And the height, though, that was another struggle. We had
That's
to lift that
PowerJack's
up.
fault.
Okay, that's PowerJack's fault.
Yeah. Yeah, the height increases because this right here is 15 millimeters too high. That's not where I specified for it to be.
Yep. 13 people are awake now.
Okay, we'll try firing it up. Got those three on. Bolts there. All the metal filings off the FETs. That'll be exciting later. Okay. Power board's in.
Ready when you are.
On your power supply.
You gotta attach negative first.
Might be helpful. I like this wireless power transfer technology they're talking about.
You can charge phones that way. Yep. Well, you still uses magnetics.
It does, yeah. Like
That's
60 volts. Just start it hot while you're at it. Turn it out 50. It's gonna take a
But
minute.
it's gonna take a while.
take a
Those
minute to
big
get down there.
apps.
Let's do what I did last time. Just turn it on and produce it.
Wow, yeah, that's
Because here's what makes me suspect that the
Alright.
caps that PowerJack is using aren't the best. Because this is about 90,000 microfarads, and those should have, well, 40. They're about double.
well. There you go.
There. There. Okay. Power supply saying 0.4, and it's definitely not.
Ah, plug your ears. It's gonna blah. 1.2 amps. It's lower.
Well, here's the thing, Sean.
It's
I don't hear a buzz.
okay. It's definitely lower here though.
No, it's still buzzing on this side.
A little bit of buzz is gonna be. Where the fuck am I meter at?
See, I'm used to the first time I turned it on, I heard absolutely nothing. But I know we are running a higher. Yeah, what's the current on the?
Less than an amp.
So it's 0.9 amps, which is still higher than I'd like. Crank it to 60 and see what happens. Actually, wait a minute. Let me clamp on it so we got a meter watching it move. It says 800, but I think it reads a little low. Okay, 800 milliamps. Crank it up.
That's 60.7 volts.
867.
So
So
it didn't hardly change
it
at
didn't
all.
hardly change at all. So it definitely needs the choke.
Still, that's less than an amp at 48 volts. That's pretty
It's-
significant.
So to be fair, this is 860 milliamps at 60 volts.
Yeah.
That's not bad because that right there is only 750.
Yeah.
So my magnetization current measurements don't necessarily prove anything in that regard. It's
So
slightly
that's
higher.
2 turns per 10 strands.
Seems to be the recipe here.
Still, that's less than an amp.
It is.
How many watts is that?
We're less, so there's 6, so you can do the math, Sean. You
No, I
like math,
can't.
right?
Go ahead, do it.
Pull out your calculator.
No. Do it in your head. You do all this in your head.
You did calculus, so go ahead.
Oh,
put it in
my
your
brain
head.
hurts.
It's math, Sean. Very simple. How many volts we at?
60 times, what are you reading? 9?
0.873.
So what? 50 watts?
52.38 watts.
Jeez, that is so low. For an inverter that size, that's tiny. When I'm being told specifically that
Other
the
ones
Ames
run-
inverters are like 400 watts sitting there.
250 to 400 watts, yeah. We're running 52
52 watts.
at no load. And that's, I'll double
Your
check.
brother did the math for me, by the way.
Oh, yeah. Must have nothing else to do. Dig, right?
That's a huge accomplishment right there. But I wonder if we can get that even lower. I don't think so. 2 turns.
Maybe, we'll see. 239.1 volts out.
It should be the same as what I had it when I was sitting over there in the house.
Well, I update the firmware, that can change.
Oh,
things.
yeah, okay.
So, there's 2 things that we can tweak with. Number 1, that core has less loss at the same core saturation as this one. So, I am seriously considering switching back to the cheaper core because this one isn't gaining us anything. The curve, let me go back to my numbers here. Wrong one.
What is the advantage to the high efficiency core then? If it's
None.
not giving us any gains, so who's ripping who off here? We paid extra for that high efficiency core, which didn't get us anything.
Yep.
Oh, that's frustrating. Send that to Jack. Jack, you're getting ripped off. Yeah. Glenn is flipping back and forth between this and the Ambassador Bridge situation.
Ambassador Bridge.
Yeah, the Canadian
Oh.
stuff. We can't even say the words right now because YouTube starts demonetizing and
Oh, yeah.
deplatforming and delisting and delifing, and they basically delete everything that you've got. Carlos says that idle power looks good for that. It certainly does look good for that size inverter. Really good.
HF cores are good when you push them hard. What's the context?
We got your brother working on.
I have no idea. So high frequency cores are good when you push them hard. So if he's referring to chokes, yeah, I agree. I agree.
There's a little bit of buzz there.
The chokes are buzzy.
But the core, the transformer itself is not buzzing. Your brother asks, are you sure of no improvement with the HE core? You haven't tested the inverter's efficiency under heavy load yet.
Well, so the only difference the core is going to make is magnetizing current. So that's no load. I've read on this, the most effective way to measure the efficiency of a core is at no load. So under load is just a matter of transfer, and that doesn't apply. So
Have you checked the FETs yet? The crosstalk?
No, but we're no load.
So it's not gonna matter.
Okay, so the old wait, hold on. The first one down there peaks. This does have a slightly higher peak voltage, which is expected. The other peaks at 125. This one peaks at 1.5. But across the entire board, the no load current of this one is almost twice that one. Across the board
Almost twice?
on the AC line. So does that prove anything? I don't know.
On the AC line?
So it might do the variac and the current.
Okay.
Yeah, the current sense. The current was almost twice. Poor roll.
I don't suppose the secondaries would gain anything at all from a choke, right?
No, no,
Okay.
the switching is all on the
Okay.
that side. So we can possibly drop the other core. It's cheaper. Why not? Another thing that may reduce current is sizing of these filter capacitors is determined by the size of the transformer. If they're too small, it will actually increase no load current.
That's something for you to experiment when you get back.
That's the on the core.
Oh.
That's the on the core.
Mm.
We're 900 milliamp solid, which, yeah, okay, whatever.
That's still a significant accomplishment for a 12,000 watt inverter.
Mm-hmm. So I expect efficiency to be a lot higher in this thing because we got losses.
Is that transformer warming up at all?
Chokes are. Transformers are cold.
I know it's gonna take a long time for that big hunk of metal to warm up. I was just curious.
This actually weighs less than that one.
60 room temperature.
Yeah. Chokes are warm. Nice hand warmers.
What? Oh yeah, because these aren't even. I was gonna say these are room temperature too.
This right here is warm. Yeah, 84, 85, I believe that. We have no temp sensors on here, but they are cold. Ooh, whee!
What'd you do?
Shock myself.
On what?
Why is it hot?
On what? It's only 60 volts. So that would be enough just to give you a little bit of a buzz.
That was a pretty good buzz, and I got between battery positive and the chassis. What potential do we have here?
Uh-oh.
The chassis should not be attached to anything. AC. 16 volts. 16, they're just capacitive coupling. DC. 47.
It's still not enough to give you a buzz.
47. Why do I have 47 volts between this and the chassis?
This negative terminal is the only thing that.
Well, it's insulated all the way around. This right here is not touching anything. Those aren't touching anything. What is touching the chassis? It's grounded. Those shouldn't be. That's not. Nothing's touching down there.
What did you touch that?
Right between here, between the heat. I put my thumb between the chassis and that heat sink to see if the heat sink is warm. I got a pretty good jolt right through my finger. I don't think 50 volts would do that to my finger though. But there's no AC potential. It's very low. 16 volts AC. The thing is, the meter discharges it really fast. If I put it on, I get 50, and it quickly comes down to 16. Why is this grounded? Why is this grounded? It shouldn't be grounded.
Where's the ground terminal at on this thing?
Right there, it's not up.
Now you're hooked up there.
But all that does is simply AC couple it to neutral. So there should be a neutral potential on it. That's all it does. But nothing else is touching the chassis. And we're on a wood surface.
What about from AC to there? Is there?
From here to here,
Yeah.
there's the transformer shorting to it. That might be the clue right there. It's AC is 30 volts on this side. Yeah, we have potential there.
Why? Is that the transformer's fault? Something touching it shouldn't be?
Would seem. What I would suspect is the transformer. Remember, the transformer is moving around,
Yeah.
and the pad beneath is not big enough.
Yeah, that's true.
We're probably shorting a transformer wires.
Oh, great.
Turn it off.
Can you slide this underneath here? This big pad?
Underneath what?
Transformer?
We got on both little things to do that. Oh, and I'm seeing wires I've been fighting with flat down on the chassis.
Yeah, it's.
Oh, right there's the bone right there. That's it.
You found it?
Yeah. That'll do it for sure. Right here. I ground up against the bare edge right here.
Oh.
That'll do it. Hands
Yeah.
down.
Good job, Sid.
Takes a penguin to find it, you know?
No.
You just look through the window while the penguin
All
does
right,
the work.
try it again. See if you.
If I get shocked. Very scientific, huh?
That's what you tell me to do.
Oh,
Should find
overvolt.
out.
Turn the voltage down.
Overvolt.
Yeah, run lower.
Oh. Oh, low.
55 is probably fired on right there. Yep, we're on. Still buzzes the same.
What? Now I'm curious. We had some of that going through the case.
Yeah, but the case isn't connected to potential, so we're fine. Here to here. Guess what? 0.2 now instead of 30.
Well, it's a good thing you touched that, so we can figure that out.
DC potential of nothing. Yeah, case is floating now. Case is floating. That was gone right there. You got enough buttons to push yet?
No. Turn off. Turn back on.
That's a Windows thing.
DC 0 plant. Listen,
920.
900 milliamps. I still say that's a huge accomplishment for this inverter that size. We figured out the shock problem.
Yeah. Hey, that's only 30
That
volts
is not
AC.
a problem with the inverter. That just happens to be what happened in shipping.
Yep. Yeah,
What did it become? How did it become damaged though?
Probably for me fighting with this to get the chokes
Oh,
on.
okay, so you
Because
did.
the
It's his
transformer,
fault. He
transform-
shocked himself. That's his own fault.
transformer bracket doesn't have the cover all the way down the base, and it's a sharp edge right there.
Yeah, but
above the
still,
wire.
that's only
30 volts.
30 volts. Why did you feel a buzz on that?
30 volts AC. It's got positive and negative potential, so you'll feel
I
right.
guess. I don't know. I've hit myself.
A few too many times.
Well, you and your parallel these two up, and then I lean up against it, and all through my arm felt a nice
Nice tingle.
jolt.
Got a nice tingle for the morning, huh? Okay.
That really burned. That was. I remember that. I had to sit down for a good 30 minutes after that. That was hard.
Okay.
Okay. Are you sure no improvement? Oh, we already did that. 52 watts idle. Billy idle for a 12 kilowatt. That's pretty good. Chinese inverters would be at least quadruple that.
Yeah, there's some at 120, 180. Yeah.
Spark plugs
Our DC.
are DC.
True that. They work at much higher voltage.
Well, yeah, what, 40,000 volts, something like that?
Just high enough to make your fuel explode. Don't tell the safety department.
48 volts DC. You can. I don't.
If you have
think
wet
so.
fingers, you will.
Yeah, I have touched 60 volts DC and not felt it at all.
So we got thermistors here.
Supposedly, if you can taste metal in your mouth, then that means you're near death.
Means you got what?
You were near death.
Yeah.
If you can taste metal in your mouth after
Oh.
you've been zapped, then you were near death.
I thought about because what I've done is take a 12-volt solar panel and put the probe in your mouth, and it tastes like lemon. Yeah, it's working. Don't try this at home.
Yeah.
Tastes like lemon.
I'm sure that you, as a kid, stuck your tongue on a 9-volt battery.
Oh yeah.
Talk about like chewing on aluminum foil or something. Well, ugh. It's a good thing that you touched that. Really. Touch some more stuff and find out if we have anything else messed
How
up.
do you touch these terminals here?
That's good. All right.
What was I going to write down? Check some other things. I guess we can start the scope testing next and look at the waveforms. So I have those written down. I do have it put together here, sort of. Of course, Jack is going to look at that and say, "Oh, you need 2-aught cable."
He's probably watching the live stream right now laughing at us. I told you, stupid Americans. Why do you want this?
down. I forget what it was. Oh well. How much of a load can you pull on that power supply?
20 amps.
Well, watts. That's 300 watts.
2300 watts.
2300?
It's 1850 at 15 amps. So what is that in 20 amperes? What are you trying to do?
Set this up so I can see it.
Oh, well, I can just turn this off.
I'll just angle it up.
If you're worried about overloading, that's a 20 amp circuit.
Let's do that Make Sky Blue still.
Oh, jeez, oh, Pete's this thing.
Pretty lousy. It probably has temperature compensation set on it. Most of the MPPTs do. You gotta
No,
disable it.
the Mexican Blue is off. The AOC is off. Maybe the amp is on. It is. Oh, jeez. So
It's
it
running
was
2 amps
off
again?
until I turned the rest of them down, and then this one decided it's gonna come up. It's giving about 80 watts.
Yeah, it's all going in heat.
So I'm gonna turn this thing down now.
Yep, all going in heat.
Annoying.
Okay.
You better battery balancers. What the heck? 1, 2, 3, 1, 2, 3.
Auto set. Well, that mode's useless.
Well, I always have it. It seems to work for me when I'm testing the inverters.
Well, here's your AC output. You can do that from the front panel with the oscilloscope function. Okay. Goes backwards.
Okay, 0 watts. We'll wait till that falls down, and then the other charge controllers kick in. They're like, "You're not charging anymore."
Yeah, I told you not to.
Oh. Orchestra of charge controllers over there.
That's what I don't like about mixing different brands. They all work so differently. Okay, low side. Let's get some voltage on this one.
Carlos says, "Do not recommend anything above 65 volts unless you have a death wish."
Yeah, got some running 66. I'm very happy with it too, right? Going off grid. Yeah, we got a lot of splash on this at no load.
Oh, we do, huh? That's not good.
The problem is I don't have a characterization from that one because we tore it apart too fast. So I don't know how it behaved in that one.
Oh.
It's on 10x, the process is 1x, over 500 millivolts. That's going to mess it up. Let's fix that. It might read right. 1x. This right here to 1x. Better. Why is it singing so poorly? There we go. So I don't know if this is load based. I remember this stuff being a bit noisy in our testing.
Yeah,
was
it
last time
didn't
you-
really move that much as we went up. You're like, "Oh, that looks good. That looks
It
good."
got large. It just sat there. We put bigger and bigger loads on it. It just stayed right there. It didn't get bigger and bigger because it kept going bigger, so it'll grenade everything. So a little splash there. We have the chokes on it, which on my test on this one so far, there's a chance we may not need the chokes.
Huh.
We may not. I was
Okay.
putting them on there, it's actually making it worse. So we may not need them. How much do we have for Miller in here, Mr. Miller? Off is pretty strong, but on isn't. That's not bad. This is a no load where I have pretty significant. So these FETs are different. Not splashing the top. Low side. If I have 2 milliseconds over, we can see that. Well, if you run a 600 watt load on this thing, with your power supply at full blast,
With what?
on this thing right here, if we run a small load on it,
Yeah, how?
we can't do 1200 watts. Do you have a 600 watt load?
Yeah, but what I'm saying is how? What are we going to plug into it? We don't have any plugs to plug in.
Jerry rig special.
I mean, yeah. Oh, never mind. You got it all figured out.
Jerry rig special. Let's wire it up hot and see if we jump, right? Because we don't have a screwdriver. Sean, you're killing me.
We've got
pull it out from down here. Get an actual screwdriver.
Good. Get a screwdriver. This on low is between 300 and about 1450. So if we keep it on low, we'll get a load and we can bring it up a little bit.
Does it pulse or is it smooth?
No, it's not really that smooth, no.
Well, I mean smooth as in, does it do everything with half wave? Oh, that's half wave for sure.
That's medium. Low medium.
It's all half
Low,
wave.
yeah.
I don't know.
Let's see. You got the space heater. I can put it on low, but it's about 800 watts.
That's as long as the thing will run it, that's all that matters.
Okay, on low, this is about 850-ish or so watts.
See the job just fine. Yeah. Guess it's on already. Just click in there.
What?
No. Okay. I guess it said low is. How do we set it to low?
Hit the power button. Okay, hold on. I don't know how this is gonna work.
Why don't you test it, figure out how it works?
Well, no. I know how
It starts
works. It starts at high. That's the problem.
It's going to overload within a fraction of a
I
second.
could.
Plug it in here.
It starts at high, then you have to go low immediately. It'd be quick. I could go. Oh,
EL, what's that?
well, EL's energy save,
Oh.
which is stupid. All it does is just turn off automatically every so often.
The faster you try, the slower it gets.
We can try it. All it's gonna do is overload the power supply.
Yeah.
If we crank the voltage up though on the power supply to 60, it might give us an extra second.
Yeah, find a bunch of space heaters, it's completely safe. That's exactly what had this thing here to do. It's only a 16 gauge wire. I plugged 3 space heaters in for a test. It's only for a few seconds. What's the matter?
Yeah, let's give it a shot. I can be as fast as I can.
Really
Ready?
Uh,
And it's on low.
okay. And I see.
16 amps, 17 amps.
And here's what I see. So once again, these specs are considerably different. We look at the Miller here, John. This right here is the proper drive. This is the Miller kick from the other side. Look how tiny that is. That's fine. We got a big kick on off. That's fine. This looks good.
You hear that, folks? That's fine.
Whereas
It
this-
says that's fine.
This one right here, you saw the picture that I sent you that has this gigantic kick coming out, and I blew the boards out.
So it's the FETs.
It's different FETs.
How?
Every
It's one letter off.
one letter can change the whole world
I
sometimes.
guess so.
One comma can mean you get a suit or win or lose a lawsuit these days. So I mean, but that is fine. I don't like the mismatched boards. Obviously, I want to put a bigger load on, but if we're dealing with that's what we got. It's going to be fine. Load test all you want.
What? All right.
So that's what I'm saying. If that's what it does, we have no issues. This would be good for production. But if we can't get those FETs, what are we supposed to do? I got to fix it some other way. You're not going to get any heat in there. What do you think,
Room
Lots?
temperature. I don't know. If there's something wrong though, we'll see it pretty close if there's a load on it at all. But
Yeah, if that's what it's doing, that is, I mean, that's as bad as it gets. I see a big spike out the bottom, but I don't care about that.
what are those tips that are getting hot down there?
Oh, you will have a hot spot on this side of the board.
Okay.
Let me show you. It's on the power jack boards. Yes, I started trying to improve power jack. It's on the power jack boards. I copied it over. It's one of those things that costs a fraction of a cent to put on.
The whole board is getting hot. Stan.
That corn's gonna get really hot. That's normal. Yep.
I'm just touching the board.
Yep.
Right there.
Yep.
190 degrees.
Shum. Copper is a great copper conductor.
Alright, I just want to make sure that's not an indication that we got a
the heat
problem.
right there on that corner. We hot on this side, hot on that side, hot in there. So it's right here on these boards. It's basically a snubber. It's this resistor right here.
Oh,
a snubber. That
it's on the
resistor
underside.
gets really hot, and it's on copper. It's copper layers both sides. The heat's going to conduct down. So that's
Okay.
fully
Well,
expected.
as long as it's not going to get overly hot.
Here's the thing. PowerJack uses an 805 resistor that melts itself.
Yeah.
I got a 2512 or something on here, so we got plenty of. I'm not overly worried about it. It melts. I don't know if you really need it, but it's on there. It's not hurting anything. Probably adding 2 milliamps.
Capsule, low temperature, transformer.
Yeah. We're not doing any low.
It's actually coming down in temperature a little bit.
Interesting.
Is it because there's a load?
It might be. I really don't know, but yeah.
So the heavier the load, the cooler the chokes are going to be. It's interesting.
I don't know. It's possible. But yeah, this right here is what it looks like. We're good.
So it says,
It'll be fine. So that's where, if we can get these FETs, this design will work. If we can't get these FETs,
yep, it's overheating.
60
Switch the
degrees
windows.
is room temperature. Check yours, Sean. See how hot yours is. No, you're too far away. You're hitting,
Oh,
you're hitting the wall.
I can't even read it, it's so low.
You're hitting the wall. Those will be cold. You'll get warmth.
60.
You get warmth right here in that area. That'll be.
Equal
You'll get warmth out of that little chip right in there. That little 6-lane thing.
See it?
That little thing right there.
80.
Yeah.
I was just looking for anything that might have been obvious. I dropped that board on the ground, so. Still works.
Yeah, I'm really happy
On
with what I'm seeing
concrete.
here. I'm really happy with what I'm seeing here. The thing is, put a bigger load on it. The spikes got bigger, but it wasn't beyond the FET turn-on threshold, and we significantly passed it. Whereas the other ones, they went right past the threshold, and poof, blew the copper right off.
Did
the
you
leads.
do a test of 6 to 800 watts and look at it? Was it, wait,
So I did 1500.
yeah, okay.
It looked terrible. I hit the 3000. I hit the trigger on my hot air gun, and there's flash and crackle and blue, half the FETs on one side out, and it kept running just fine. I don't know if that's because of different design or different FETs, but it just melted the copper right off the
The only thing
sides.
is, it's gotta be the FETs,
It
right?
didn't explode the FETs. It just blew the copper out, and that was it. And it kept
Traces
running.
blew out.
Blew the traces and the FET gate resistors out, and everything else kept running just fine. Like, if that's how they're going to fail, I like that. I don't like the big explosion with parts flying everywhere. That's not fun. Okay, pop that off, and I will do characterization tests for low load, and we can get.
Be rolling over a screw or something.
Oh, okay.
Nobody's talking, but everybody's watching.
How
Almost
many?
20 visitors watching right now.
Glenn
Find a bunch
says-
of space heaters.
Yeah, that's what I was going to do. Did I'll change it all after I found it was grounding it out? No. Because there's only one potential. I got my finger in the way of the potential and got shocked. But no. If the chassis was grounded, we would have leakage through there or serious power flow through that wire. But it was not grounded, so we're fine. Okay, characterize low side. Start with that. Zoom in. I did all these tests and measurements last time I was up here in January. July was it? June, July? Remember, got a lot of measurements and tests.
It was warm out.
Yeah, I kept hitting the save button. Well, I get back and find I had that on, conveniently, the Linux partition. The oscilloscope didn't throw an error. It said saved. Every time I push the button, I go there and check it, and it saved them on a little itty-bitty tiny partition, the boot partition. Ran it out of space, and I only had 5 pictures instead of 50. Like,
Way to go, Linux.
this runs Linux, by the way.
Yeah, Linux broke itself.
Okay.
Alright, let's see.
I'm going to move the live stream down.
No, it's alright. So, if you're just joining us, Sid fixed it.
You said I broke it all day, huh?
But in all seriousness, this looks good. This is what we were seeing last time, so this is good. So with the new transformer, well, it's a different transformer. It didn't hurt anything. It doesn't look like it helped anything, but it didn't hurt
Yeah.
anything. As far as this goes, when I'm talking about load testing, we're gonna do that later. But as far as this goes, we're good. So far so good. Right now, so far so good.
I will, I don't want to do that, don't have to. Well, case of life.
Ah! Plug your ears, everybody.
Don't want to do it, but I have to. We got to get the current limit thing here figured out. So once we do a load on, see if I actually test that here. See if it shows over 800 watts. It should. If not, I'll have to change the resistor and turn the gain up.
I'm not 100% sure if that's really 800 watts. That's the
You were saying
problem.
800 right here, which this could be calibrated. Okay, this is the part I don't like to do, but we're on the power supply. We don't have battery.
Ah! Cover your ears, everybody. Sid likes blowing stuff up.
Holding it on the gate. If I move it over a tenth of an inch, I hit the drain and blow everything out. Yeah, that looks nice. I'm not, no complaints about
Take a picture of that. Save it. There you go. Good job.
Okay. Now I gotta do the high side.
Oh no. Cover your ears, everybody.
This goes, I can't get on that screw. And I definitely don't want to fish under there.
Let's assume that it's okay.
Well, I gotta get on that screw. And I can't poke under there because there's connections there. I can't get in the front. I can't take the front off because I designed it this way. Isn't life great?
Why did you design it that way?
Because I wanted to.
I know engineers. They love to change things.
Put that clip in and get copyright struck, huh?
Yeah.
That was a good clip, though.
You were an upper Star Trek fan, were you? I was a Star Trek fan, not a Star Wars fan. Now the comments can light up.
That a polarizing subject.
Oh my god, it is. I worked with a guy that was all about Star Wars.
Yeah.
And if you even mentioned Star Trek, he would beat you up.
Okay.
He was absolute diehard Star Wars fan. And the kid was like 21, 22 years old. So it's like he grew up with Star Wars in the theaters and so on. Maybe in the later episodes, but not the original trilogy. But my god, some people just wow.
Oops, I hit that too soon.
Uh-oh.
I guess things in the mess, I don't like that. Okay. So these FETs are definitely much easier to drive. With even the lower resistance, or the higher resistance, we're having clean transitions.
Glenn, the idle current did not change at all when we fixed that transformer grounding
I
out.
think we've answered that 3 times now.
Yeah.
I keep catching myself. Wait a minute.
Well, it's hard
Yeah.
sometimes to follow the live stream. You
Yeah.
can't hear everything we're saying.
You always like both?
Yeah,
Oh, Star Wars.
Star Wars, Star Trek fan. I prefer Star Trek. That's just it. I appreciate both of them, but I'm not a fanboy of either. I just preferred Star Trek because it had a series that was attached to it, whereas the movies were just movies. And yes, I know they had things added to that, like cartoons and things like that, but like the Clone Wars, and I know that they've got the new show on.
Can
What
your
is it?
power supply crank at 058? You can crank it to 60 to get more voltage to work with.
60.7.
Can you run 1800 on that?
No, the power supply cut out at about 1400. This is a 1500 watt power supply.
Oh, okay, okay. Is this 1500 watt space heater?
It's about 1350 to 1400 depending on. That's probably not going to come on because you tipped it upside down.
Well, it didn't overload. If it overloads, those happens if we run at 1500.
I can try. It's on low, 16 amps.
Then we double would be 32.
Yeah, that's gonna.
We'll trip it out.
Yeah, it's not gonna handle it.
Okay.
Unfortunately.
Well, turn it back down to 50. The back you got at 58. What you had it at. All right, compare apples to apples here. 57.2 is about right. This is saying 750 watts. So if I measure this, see, actually, I'll check. Let's look at the new calibrate function on here.
You okay?
You what?
No, go ahead. Keep doing shit.
Calibrate readings. 6.3 on the output. So put this over
Oh,
here.
jeez. My kilowatt meter is behind the fridge.
Okay, so it's reading slightly high.
Oh.
So here's what I'm doing. You see right here, Sean.
Yeah.
So what I've done on the calibrate screen now, it shows you AC out and AC in amps in 120. So this is 240 scale. This main screen will say 3 amps.
Okay.
This says 6. I have a 6 amp load, 6.3. Base read correct. It was reading about 6.3.
Okay, so that is for the current sense limiting.
This is for the AC input out current. Battery current limit, I have no calibration, no characterization on that yet.
yet. Okay, but you will.
I
Just
will.
want to make sure the customers can't get to this and then mess around with it and blow their inverters out because they were screwing with the wrong setting. You know what I
So
mean?
this one right here would just be a readout. If you had a current sense limit, a current sense calibration, you read out only.
Okay.
The CPU has a hard code number. You have to void your warranty to access.
Perfect. That's good.
So, yeah. That I thought that through. If you mess with that, you can blow stuff up. There you go, 700 and some watts.
Yeah. Yep. Sid mentioned it. I appreciate that. I think he's referring to us. You saying that you had mentioned it.
Mention what?
Ooh, I love this inverter. It's nice and warm. It's putting out some heat.
Transformer's cold.
Yeah, the transformer's cold, but the
We're running-
space heater isn't.
We're running at about 1%. Is it 1%?
600 watts.
That's more than 1%. But appearance and set the percent back on.
That's 5%, isn't it?
Let's see. Let's turn the screen on and see what Linux says. 5.9%. Bingo. You were good at calculus. Come on.
Oh, hey, don't ask me. You put me on the spot, and I don't know what I'm doing.
Oh, okay.
If I volunteer the information, I got it.
Okay. So, time to redo actually take another screenshot. I'm not doing that gates because I don't think that's, I did on that side, but not the low side.
It'll take quite a while to eat up the transformer.
Oh.
But
Okay.
the old one,
Mhm.
it would hover about 105 degrees or so at idle, not doing anything, when it wasn't on AC.
Correct.
So when it was just sitting there doing nothing, it would get up, it would eventually the whole thing would just warm up to about 100 degrees or so.
Yeah, I can see that. I don't know what.
So if we let it sit there at idle and came back in an hour and a half, I'll bet you the transformer would be
Well,
about
I'll
100
leave by
degrees.
then, so.
Well, yeah, but I'm just saying, it takes a while for that thing to
Get up,
to get up to temperature, yeah, when it's not loaded down.
I'll pop this on here. Let's
Oh no,
put this
here we go.
on.
Anytime Sid has a probe. Ah!
I had a knife earlier. You weren't concerned. I only broke half of one of the buttons on your microwave or your oven.
Sid broke half of our oven, but fixed the other half. So
I came here and none of it worked.
we're 50% better than what we were.
Probably should write these down so I don't forget what's what. Okay. Screen. Zoom in. We have what? Because that is, I mean, it's got a turn off spike, which is interesting, not a turn on spike. And that's 2 milliseconds in. That looks like the deepest part of it. That's all I gotta do on that side, and I gotta do the high side again.
I suppose I should get some battery cables ready, because the one that you're using in the inverter actually went straight to the inverter from that breaker. So I'll get some cables ready. I'm really, really legitimately curious about. Shorter ones in here. I am full of battery cables. There we go. They're both the same length. They certainly are. I have so many. Boy, Windy Nation. They got a lot of my money, that's for sure. I have so many of their battery cables. These are 1-aught.
Let's indicate again.
I've got 2-aught cables here from Windy Nation. These are all welding wire, by the way. Windy Nation.
I'll never buy that
Yeah.
THHN again. I bought some to start with. Well, then why are you even bend the stuff?
I love that stuff. That's why I
just
use
the
it.
terminals
Yeah.
off.
Here's 2-aught.
Never buy that stuff THHN
Here's another
again.
set of 2-aught.
Yeah.
I mean,
I actually,
I have bought so many of their cables.
this means I have Windy Nation as well. This looks identical to the ones I have in my charge controllers. It's welding wire, great
I
stuff.
actually thought about at one time like this is. This is 4-aught. This
Yeah.
is really gigantic stuff.
Yeah.
This here, this is 4-aught Windy Nation stuff. I thought about reaching out to them and
As for sponsorship,
not a sponsorship, but selling their
wire.
wire if they could give me a discount.
Well,
Because I use all of their stuff and it's really good stuff. It's properly crimped. It's not power jack crimped. It's actually properly crimped stuff. It works really, really well. Listen to me. I'm standing in front of the camera going, Windy Nation, they did not sponsor this program. They probably don't even know who I am. Who's this guy?
well, they're Windy Nation, and they know we've been talking about wind power, so Like when things
I
change.
do really like their cables though. They're very high quality. They do a great job. Sponsorship over.
We have, this one has the spike on the low side, which, as long as that's filtered by the chokes, we're fine.
Oh, looks like the live stream. Oh no, that's you just being still. I thought the live stream cut out.
Yeah.
There's 17 people watching and nobody's commenting. Say something. Say hi, Sid. Besides Glenn
Besides
and
Glenn-
Carlos.
Besides everybody, right?
Besides everybody who's already been talking. There's not 17 individuals talking. There's Ryan and John, Carlos and Glenn. Battery cables and fuses going to the inverter would be the weak link. Carlos says hi.
Like
So,
this at all.
that looks clear. Somebody brings something interesting. We've talked about this before in videos, but I just want to make sure
On what?
everybody understands what I use.
Oh, yeah. Big old things.
Actually, this is what Sid recommended. These are 400 amp Heinemann fuses. Eaton Heinemann.
Breakers.
Huge, yeah, breakers, sorry, breakers. Huge breakers. Massive. And I have 3 of these. One for eventually each inverter. So,
Shunt on it too.
yeah, I didn't take them off of this. On the 300s I did for space saving, but
Okay.
I didn't take them off of this.
But the thing is, with these right here, this calibrated shunt on it, what does it say, 25 millivolt, you can actually put an ammeter on this and it'll give you an accurate reading. So
That's awesome.
they're nice.
So anyway, this is what I use for the actual breakers to the inverter. These are massive, massive. Use wire only above 200 amp. Max wire size 250 MCM. Mount on vertical surface. Sid. That's why I moved that up so it's not horizontal. You'll be fine. Maybe that's why that 300 wasn't tripping, because it was sideways.
It was half tripping. That was a weird thing.
I can really hear this power supply down here.
Playing a little bit, or running its fans.
It's got a, this must, I don't know, something, maybe it's a load. It's like a zzz,
That's what I've been hearing.
zzz. But the load is the same.
It's getting ready for spring like a good old frog. No need for those breakers. Oh, come on, you need breakers. I don't like fuses because once they blow out, you gotta buy another one. It's
Well,
60 bucks.
that and most fuses, they blow instantly. So if you have a surge, then you've blown your fuses
Get a
out.
slow blow. And the thing is, people
Yeah,
say,
you could get a slow blow.
at the end of the day, your breaker, where is it? You put it.
I put it back.
Okay. It says 25,000 amps interrupt current. Most fuses are rated the same.
Mm-hmm.
You don't have a 300,000 amp interrupt current fuse. So I mean, the ratings are about the same, and I can reuse my breakers. I just go click
Yeah.
power off.
And as many times as I turn this off and on and off and on because we're experimenting on it, I need a way to
Get the
shut it
ratchet.
off.
Let's unscrew this when
Yeah,
it starts to go.
I need an easy way to shut these things off. So,
Difference of opinion. Some people like
Yeah.
fuses. I mean, go enjoy it. All the more breakers for me.
I had too much coffee out there
Well,
Keep the people entertained, Sid.
Please filter that main board. The 8 there. Is that power supply accurate for anything? Let's see. B75. Not doing that because I don't need to. So. Oh yeah, homestead. The only explosion in the house. Well, technically, not the only one, because I did have a few explosions, small ones. Trying to fix that oven. But she definitely had the biggest one. That was pretty exciting. I thought the oven fell out of the wall. Marine thermal breakers. Yeah, marine thermal breakers are great. I like the magnetic ones because they're a lot more consistent and not affected by temperature. This DS1, this is no lube. No load.
Not worried about it right now. All right. Gentry Homestead says, hi, Sid. And Tiffany says,
Unlike the last time the whole house shook.
the whole house shook. Oh, yeah, she heard the major explosion in the.
Well, that was different than having a pressure explosion.
That is weird. Isn't that fascinating though? How loud those things
Oh,
are to
yeah.
shake the floor
Those
all the way
things-
upstairs.
Those things like set off a bunch of guns. They're loud too. But yeah, Danielle had the only explosion in the house. Yeah, you heard that, right?
Yeah, I heard it. Felt it.
I thought the
Felt
oven,
it in the
I thought
floor.
the oven fell out of the wall. She just blew the pots apart. I told her just heat it up on the stove. Just don't do it too high. So it came apart.
Yeah. Except when Sid causes sparks, he's like, "Oh, that's not supposed to do that." Instead of me, where I run for cover.
The runner power keep going because the oven up there. Somebody pulled all the wires
Well,
out.
hopefully the breakers would stop that, but apparently they don't care.
Somebody pulled all the wires out of the board without labeling which ones went where. So I had to figure it out. And there's 4 hot spade lugs
That would
sitting out there
be,
in the open.
that would be
I'm trying to play with it to figure it out, and they touched ground. That was
Blake. Blake.
That was kind of
Okay,
exciting.
Bobby says you guys are skipping lunch. Sydney's brain fuel. No, we had plenty of brain breakfast.
That's high side. So that is on the screw, and that's closest. Okay, so I have 3 is overview gate. Row side gate. And we have
Transformers heating up. We're up to 78.
row side.
Chokes are cooling off. They're at 78 as well.
Huh, room temp on this joke.
70 on this choke here on the end.
Come on, get a little closer for once. We're measuring the wire.
No.
That one is cool. Of course this is cold, Sean. Look at it.
Oh. Somehow this thing cooled off. I don't know how.
Room temp. I wonder why.
85 on that choke.
It should be the same.
79.
Huh.
80.
Why is that one hotter?
Quite a bit hotter.
It's the one by no, there's 2 on that bolt. I don't get it. Why is that one hotter?
Something internally wrong.
It could be a different ferrite material. I don't know.
Oh yeah, that's no problem. It's cooling off a little bit. It's 83 now. 77. 77. No, 80. 70.
Where do we need to find
Well, the
more accurate
transformer-
machine?
Transformer is warming up now.
Slowly warming up.
Yeah,
Expected.
that's expected. 82 degrees.
7. This is close.
The heat sinks are at 66. There's still room. A little bit of both. 60 degrees on the DC side.
Separator. Okay, then we switch to key resolution.
How hot will these chips get that are on the MOS boards?
I'm not too concerned about them. It's a resistor. 127 degrees. I don't care about
Yeah,
that.
okay.
It's a resistor. That's gonna be cold. Come on.
Just checking.
It's gonna be cold. I better not be cold or we got bigger issues.
Cold as a penguin.
Aha. Nicely insulated.
I didn't look up hard enough. I'm just trying to measure all the chokes, and you left a choke here that we're not even using.
I couldn't help it. I had to tease you with that one.
Oops. Camera.
So as long as the increased loads maintain the same noise on the FETs and it doesn't keep getting worse and worse, you can slam load test this all you want in like 4-hour drive back home. You will want to put thermistors on. That's what I need to write down. I need. Do you have spare thermistors laying around to take a small handful, or you don't have that much spare?
I do have spares. You're gonna need to put connectors on them, but
I got connectors, so that's not a big deal. Oh, first. Otherwise, warm up there.
Well, I reached my hand up here and said, "What's kind of warm up here?" Well, in front of fence right there. All right, where's my button? Here. Here it is. I'd like to order some extras.
Yeah, we need
And
to.
if possible, we can take whatever you want.
Okay.
I already set aside 6 for that inverter,
Okay.
so take as many as you need.
There's a jumbo right here. Is these the ones you set aside?
No,
Okay. Where are these
those
from?
are going to the inverters, the 2 inverters that we took apart.
Okay.
6 kilowatt inverters.
So these are assigned, and I'll set them to the side.
These are the ones that I have set aside for
Yeah.
the 12 kilowatt, yes.
Okay. I actually need thermistors for Carlos, I think.
All right, we'll take as many.
Well, I just needed to set one set or two, but I also have to get pictures to tell PowerJack how to make. That's just a station.
Yes, that's the for
Comm cable.
whatever you call it.
Yeah, the
feedback
cable. Yeah. You got to get one. These pairs straightened out. So you have these set aside for that inverter.
Yes.
Okay.
Because I got ones that had the nubs on the end for the transformer,
Yeah.
3 nubs and then 3 rings.
Okay.
These, you can, if you want, give these, I put some hot glue on them because I took some of them off.
Well, I don't like reusing anything hot glue.
Yeah.
That's
Dip the hot glue down there to keep the, all right,
I'm not using
whatever you
those.
want.
Those, I have to cut the ends off, reprint them. The problem with that is when you get glue in there, it's going to be a
Well,
spacer.
why don't you just take these that are already on this transformer? Just heat this up. I didn't put any hot glue on any of the other ones, other ends. Just heat this up with a heat gun a little bit and the thing will just come right off.
Yeah, we got the old patch ones.
Oh, never mind.
I mean, these right here, I think.
Just as long as I have 3 nubs and 3 rings, that's all
Okay.
that matters.
So I just need to characterize these so I can show Jack what we need. And thermistors go from here, so
It's not that far to travel. I already laid it out. We can get 1 thermistor on this side, 1 thermistor on this side, and then I've got wherever I want to put the third. I was hoping to put it back
I
here.
would actually say there's not really use to having it here on the sides because that's where the fans blow straight
That is
on.
true where
So
the fans are at, but then how am I supposed to get it into this clunk?
I'll sit back and watch.
Yeah, never mind.
Bring them
It
blocks.
sounds like to me I'm gonna have to glue the thermistors before I set the transformer voltage, which is fine. I can do that. That's not a big deal.
I mean, we can have PowerJack glue them on. but
It's just usually the last thing that I do is the thermistors, the very last thing in the assembly process, because I want to make sure the board works and all that stuff before I go to all the trouble of thermistors and stuff that is not as important to start out.
Yeah.
So, I mean, yeah, I can install the thermistors first and then just not plug them in, test the board, make sure everything's fine, test the inverter, and then plug them all in. I mean, either way, it doesn't matter.
Is that big of a deal to put them on? I mean, just plug them right in here. I mean, if it's on the Wi-Fi.
No,
I
if,
understand.
if the thermistor itself is bad or something's
Oh.
wrong with it and I have to replace it, then I have to take the hot glue off and then start all over. That's why that's the last thing that I do.
How often do you find bad thermistors?
Not very often, but when it does happen, it's a pain.
Yeah. There's that one customer that had one.
On a very rare occasion, I'll get one thermistor that won't read at all. It's like the connection's not there, and then I'll replace it, and then it works.
So the issue we had was where one of the thermistors actually shorted to the battery positive terminal.
Yeah.
We've had that happen occasionally.
But you said that you fixed that problem or prevented it.
I fixed it from blowing the CPU up.
Oh yeah.
So it's still, the symptom for that, if the thermistor is shorted on the positive heatsink, you turn the inverter off, and it won't turn off.
Well,
The LCD will stay on, just say turning it off will stay on.
well, so far I haven't had that problem.
Customer in the United States sort that one that way. That's Where'd that come from? We're finding your bench. You'd have caught that because you turn the power switch off and the screen won't go out. I think you'd see that.
Yeah.
So, yeah, shipping stuff. This high side overview. High side. Screw. That's close up. High side. Switch off.
I can't believe there's 17 people still watching. They're not bored.
We're on background.
Yeah. Your brother, he's waiting for keywords like analog and
That's the end, so I don't have close to the screen. Okay, well, we have those characterizations, so it's up to you what you want to do from here, because that looks good.
we can glue some thermistors on the sides there so we can monitor the temperatures, or we could just hit it with a 12, well, not a 12 right off the gate, but let's say 6,000 watts and see how the FETs do.
I just
and-
need to throw a scope on the low side gate and make sure the spikes don't start getting too high. If it's good, just pop loads on.
I would rather get the thermistors on there now while we got easy access
the bench
versus
here.
getting it over there and then trying to haggle with it.
Yeah.
Now, okay, so the temperatures, which one's gonna get hotter on the DC-AC side?
Ideally, they both be the same. But with the crosstalk, or the Miller capacitor, it's not crosstalk. Crosstalk's different, which hopefully the chokes will take care of. But with the Miller capacitance, the low side will take more of the brunt.
Mind if I cut the power to the power supply?
Let's turn it off here.
Yeah, but it would drain the caps. No, it
Oh.
won't.
That's how we did the first test. Let's turn it back on. It'll drain it pretty quick. There's on.
There it goes. 35 volts
Yep.
instead.
And it's off. Off-ish.
Off-ish, yeah.
Let's discharge the battery.
It does take a
slowly.
longer time to stay red before those caps completely discharge.
Yeah, they take a while. I'm pretty happy with those caps. The question is whether China can source them, because they're not
Do we
cheap.
have any alternatives?
I'll just tell them you have to get a 5-lead cap. The problem is if they get something that's counterfeit, we'll have to have Jack get a capacitor ESR checker. That's how he'll know the difference.
Oh, really?
They're not terribly expensive to get a Chinese capacitor tester.
Well, the ring ones, obviously, well, how many are we gonna test these?
The front.
I mean, I don't like putting them in between the battery positive and the heatsink.
Yeah, I don't either. Yes, I did last time I put it beneath the one here, which is why you're missing it on this side. I don't
Good.
like to do that, but we have no holes down there. So
We could add,
I really want one right between the sets, if that's.
that's kind of, ow, doing the same thing you were doing. Corners, shrap. That's
Yeah.
warm, Sid.
So is the low side. Gently warm.
That's barely,
I'm not concerned about that, it's gently warm.
so we gotta get some thermistors on here. This thermistor will be easy to get. There's a hole right there that's already threaded for us,
What one?
right here.
Well, these two are identical heat sinks, so I like those. There's one on top of the fence right there, right on the side.
We need 3 for the main board, 3 transformers. We can monitor each one of these. I don't know if that's necessary for a production unit, but I like to be able to see all the temperatures.
Yeah, and you got a bunch of channels on these, so you can see all of it.
Are you taking those thermistors with you?
I just need to take a picture of these
Oh.
here, and rewire them through so they're right.
All right. Get started.
Okay, so what I need is, because I have it marked, MOSFET's on the bottom, so MOSFET needs to be the screw. That one is. you get pulling out here, else I'm not fighting with that with them little strands of wire.
Moss. That's a Moss. There. This is transformer.
You see on the board, it's marked with M.
Yeah, I just have to line it up so that I know which one I'm taking out
Oh,
first.
okay. This one here. Yeah, the main board's gently warm, but I'm not concerned about that. Yep. Heat sinks are gently warm, that's switching loss in the FETs, that's expected too.
The nub.
Where's your,
You got a nub right here, but you're taking pictures.
well, I want to swap one to the other because we need,
Well, here, do you want? This is a main board one.
okay, so I just need the screw on one
This is
side.
main board.
I need to have a blob on the other
A
side.
nub. I call it a nub.
Okay.
I don't know.
Yeah,
I don't know.
so we pull the nub out this one, slide it in there, now have them.
Okay, give me one of those. I'll pull out a nub.
This is nub, so you gotta, I'm looking for it too, it's right there.
Yeah.
That's got 2 nubs in it. And I gave you a box of these, or a bag of these.
Wait a minute. Which way is the nub? Main board's on bottom, so here. This is the one that has to.
We're gonna have black.
Yep, this one
Black
has-
is fine.
Yep.
Color doesn't matter, just to get it right.
Wait, which one's main board and which one?
Penguins.
I'm never gonna forget that. That was. I've
Penguins
never
would get
seen
over that.
you. I've never seen you so mad.
You don't know.
Never seen you so mad. I don't remember what word you used. It wasn't a swear word, but it's like, whoa, shit, just swore in his own way. Okay, so this is a nub.
Okay. Let's see there. It was all fun and games till you got Danielle involved. It's like, come on, you're going too far now.
That was
Danielle
fun.
texts Tiffany, come on, give me a break.
After you're already fuming.
So I printed it on the board. Come on already. Okay.
No comments. Everybody's just watching. Right now, all we're doing is getting thermistors hooked up so that we can monitor the temperatures, and then we're gonna take it over to the battery, and it looks like the sun is actually kind of bright out there, so that's good. It's still cloudy, but at least there's a fair amount of light coming in.
Yeah, we're picky on this. We almost want a red one on it because I don't even see what's what. When it goes black, it's hard to see. What do? Like that, maybe they can see if I do it that way.
I can worry about the fans and getting, I mean, I can do it right now, I guess.
I'm not certain the case is going to fit on there with the wires dangling around, so that's going to be a challenge.
Lit.
Yeah, lid.
Did you put hall sensors? Yeah, you did.
There's one on it, not 2.
Yeah, so that's something I'm gonna have to do a little bit later. I don't have to do that right now.
Okay, so there's one.
Where's the, oh, okay, we didn't use input yet. That's fine, that's fine.
Yeah, but it's not put in
Yeah,
yet.
I'm not worried about that right now.
That's a really, really long MOSFET one.
Some of those could probably be shortened up, depending on how you specify it.
Yeah, so the MOSFET ones don't need to be huge. MOSFET ones only need to be, what, 100, 200 millimeters long? This right here is 300? That's 350. We're at 200. And from here, it just needs to go right down straight through there. That's too short for this side, so we can't say 200.
250?
300 would get us down there with some room to spare. MOSFET side, only 300.
Okay, good. I'm gonna line this up, so the lid, gotta get this right. The lid goes this way, correct?
Yep.
Okay,
Uh-huh.
so fan, okay, got it.
Going in on both
Yep.
of them.
This is the main board fan right here, going in.
So here's the thing, if I specify it, how long do you want those transformer thermistors to be? It looks like we need way more than,
Depends on if we're gonna put one all the way on the very far side. I don't think that would be a bad idea. The only problem is I can't glue it because I can't reach in there between the.
You can drip this glue down the back
I mean, I
channel.
could. Well, see, with those though, I like to put them in between a winding
Yeah.
so that they're sandwiched in there. That way they have as much contact as possible.
Let's just put those at 400 millimeters because what do we have here? What's the long length?
But yeah, still, I didn't even think about that. How am I going to? I suppose that's going to be a challenge.
So let's just figure from here, Sean. What's this right here? This is 400 millimeters. From here, you all the way back to there. Not very far back. You can get all the way back there. That's 400 millimeters.
That's fine. It's just, how can I get back there with a glue gun and?
Miniaturize it. I'm just saying how long, because I put on spec.
But you see, for here, it's like I can squeeze and push in between. See how?
Yeah.
Squeeze it in between.
Yeah, we
I
got-
can't reach that over there.
We got a
So
good bit there. So that's what I need to do is say 400 on the transformers, 300 on the FETs. That way we have characterization. Those are two more rings.
let's see if they can get it right.
Well,
That's
that's
you said.
so far the track
600
records
mil.
are rather longer than too short.
Yeah, it's a lot of cables to manage. I don't like the possibility. I can use zip ties, but it starts
Yeah.
to look really ridiculous after a while.
Yep, it does.
Shorter the better. That's all I care about.
You make them 100 if you want.
Oh, yeah.
You'll reach 2 FETs, that's it.
Those fan filters should be here today. They're supposed to be delivered on Saturday. So
Didn't you get, I saw a box out there yesterday.
That is books.
Okay.
now. Everything I order seems like it comes from California. If we lived in California, I'd get everything in one day.
Who wants to do that?
Yeah.
I mean, a lot of people do, but I don't see what their allure is.
Oh, more people are leaving California now than they ever have.
Yeah, that's a good thing, but also a bad thing.
We won't get into the politics. Somebody's gonna be offended.
Some people offend our inverters not green.
Yeah.
Painted green, I mean.
Painted green.
I painted penguin first. That's good. I got these primaries to lose. I don't think we got, no, we don't have clearance for that, so that's gonna be tight. Squeeze that down.
Oh yeah, it's gonna have to be extra clear where the transformer's at because it does not have doesn't have a way to protect the blades. We have to make sure nothing can fly into these
Blades, yeah.
these blades. There's gonna be a lot of a lot of pressure. So I'll have to make sure that nothing comes close to this fan here except for the transformer itself.
Yeah, now I got these wires to lose. For prototype purposes, I mean, I don't recommend doing it for production, but you can squeeze them right over here in front.
You are gonna shorten those up though, right?
I don't know, because
Do we need chokes ever around those? I guess if it's a 24
The
volt.
60 you will.
Yeah.
the 60 you will, and if
60, just 60?
there's 60 or 36, if these are ever used, you need a choke on them.
Are we really doing 60?
Possible. We gotta keep the
Well, I
potential
just-
open.
I don't wanna, I don't know, engineer for something that we never use.
And caps are 80 volts. Yeah, things we run in the red line do 60 volt.
How many people would actually use a 60 volt converter? And we would have to, what do we have to, no, the fans go up to 72 volts.
Yeah, well, that's, we need a step down power
Well,
supply.
Still, that's a problem. A 48 volt inverter can go all the way up to what, 66, 67 volts?
Mhm.
So 60 volts, add 20, that's 80 volts
It
right
is.
there.
It is.
So that's too high.
Well, that's what I'm saying, we need a step down converter to make that function. So, is it something?
Not
along-
just fans, but also capacitors, right?
That's what, well, the capacitors are rated for 80 volt. Those can handle surge, that's the spec, has a surge rating, but the parts, the chips don't. So that's my concern on those.
Seems like to me we would have to engineer it specifically for 60 volts.
No, that's what I keep saying again. Put a step down converter in it. For the logic, it'll be fine. As long as the FET drive doesn't have a problem with the higher voltage.
Okay. Well,
That one's out of the way, sort
it's
of.
ready.
What do we do with this big old wire here? Run it around the top?
I don't know. I don't like how the primaries on the backside are blocking the air. That's gonna throw a little bit of the cooling off. Is there any way for us to move those to the one side? Bundle all, because you got 1, 2, 3, 4 on this side and then 2 on the back. Can we get all 6 over here?
I was trying to get anything on there, but
Even if these 2 here were facing out this way. I mean,
you can play with that later.
no, we're playing it now.
So my challenge with reducing the length of these things is, look what I did here. I did these with 2 terms,
Yeah.
and that's smashed in there, that's it. So, we're right here straight to the board, so if I make it much shorter, we can't get any turns around it. So here it comes
We might
out.
have to leave it the way that it is, unfortunately.
Well, we probably can shorten it somewhat, as long as they're out here instead of back there. We'd be able to do it. These right here are a little longer.
Are these? This is are those 10s? I thought they were larger than that.
The LCD right here. Ooh, I don't like how big old hunks of wire in here.
That was loose. Wait a minute. It is a 13. There was no force on it at all. There was no torque. It just kind of fell off.
That surprised me. All this weight.
Well, that's not good.
No, it's not.
This thing didn't complain at all about pulling those out, so that's why I thought I had the wrong size. Should be able to, yeah, that's what I was thinking. That way we got airflow at least behind there.
Like this. Now we're running to the side.
Well,
There you go. You snug it back down.
this fan's not gonna be an issue right here.
But if I narrow the case down to the width I specified,
Wait a minute.
with 15
This
millimeters
is gonna
less,
be this way.
Yep.
That,
still is fine.
it's fine? You don't, okay, so you don't think that there's any possibility that these could be sucked into that?
They're not much sucked into, but shipping could move it. So that's where we have to zip tie these to the bolt or something and hold them out of the way.
Okay, yeah, then we'll have to do some zip tying.
I want to shorten the length of those primaries, but there's not.
Ding, ding. Oops. Okay, well, that'll enhance our cooling a little bit.
Sure, these are tight. Yeah.
Yeah.
All I really have left to do is getting this. Look how long this cable is. We don't need a 100mm cable.
Well, I mean, why did I make that so long anyways?
Because you wanted it longer. I mean,
No. Oh, I remember, because I kept having to pull the lid off. I was getting sick and tired of having to the 4 screws. So I said, screw this, I'll just make them longer so I can pull the lid off and the LCD can stay right where it's at.
now we have all these extra long wires.
Yeah, well, I mean, if for production it doesn't have to be that long. That was just for me because I was sick and tired of having to disconnect the LCD to get the lid off.
Way so much. Yeah, we'll see about wire lengths. We didn't have anything that long, but
Yeah.
this right here, we ordered 500, so we use those till we use them up, then we can order something else. Unless you, I mean, what was it, $300 for 500, something like that? 200?
We've got zip ties, so if we need to zip tie them together or whatever.
Yeah, we might need to move the LCD down here just simply because
That's
there's a
fine.
mess up there. I don't like it down there like that, but there's a big open space right here we can put it in. Up
This
here.
won't be in the way, obviously.
Correct. Now there's gonna be absolutely nothing here in this corner. I don't like that look, but there's nothing there. So up here, we're dealing smack on top of the transformer.
I don't like that.
If anything,
And
shit.
besides, you said the transformer can interrupt or interfere with the.
It has been.
So maybe a good idea that we don't. Did you take your pictures you were supposed to take?
Of those, yes, I got the picture just to say what one's where. Take a characterization picture of here so I know what we're looking at. What a mess of jumbled in this chassis.
That's stupid, Americans.
It's quite a mess.
Jackson will laugh at it.
Look at the design.
Yeah, but the goal is it's gonna do what we said and then some.
Exactly.
Okay, I guess you gotta put those on
Yeah, I mean,
this way and.
okay, it's a nub. Is it a nub? Oh, you already got them?
One,
Here's a nub. There should be two nubs. Okay, there's two nubs for the board.
we don't have another Moss one, but
Wait, you installed it without one for the boss?
I just plugged it in, so you handed it to me.
Well, I wasn't done with it yet. I thought you were taking pictures of it or something.
I did.
Well, I thought I had some that didn't have any ends on them. No, all of them have ends on them. Oh, there's one right here. No, that's a nub. I glued that one. I'll just pull it off. You're gonna have plenty of thermistors on that transformer over there. They could put 4 on there or something.
Well, I see a few extras.
I was really watching the transformer temperature.
And the worst part about these thermistors is they're not an easy value like 10K, they're 15. I get 10K thermistors all day long, these are 15s, they're special orders. Oh well. Thing is, with the new design here, I can easily change resistors on this board and switch to 10s, it'll be fine.
Whoops.
You do, smash it in,
Yeah, a little too far. I've never done that before. Maybe once.
first time for everything. And your battery cables will take these 10 mils.
Yes.
Okay. There's that 3-phase motor down there.
Yep.
Haven't had too many people asking about 3-phase lately.
No.
Good.
If you want. I'll just grab another. This is a nub. Oh, geez, old Pete's. I already had it out and ready to go right
There's the
here.
tweezers.
I had this one out and ready to go. You took it from me and then I lost track of it. It's your fault. Thanks, there we go. Now we got it all ready. Okay. Nub. Let's see, we're gonna go through here. Nope. Through here. Okay. Let's find a good spot for here. Hey. There's spots.
Good, almost as good looking through a window.
Oh, this is actually, the windings aren't as loose as the other one, but
Set.
they're nice. And I can zip tie it right straight to these primaries. So it won't move around on me.
Okay, CPU cable there.
There's a box there on the bottom shelf.
I just see we got several there.
Yeah, we got like
Well, that box,
500 or something in there.
the box probably has, 300 or so in it. That's not it. That box is something else.
The box on the far left is the tall brown box.
Oh, okay, yeah.
That's
we got a
CPU
few in there.
cables. Yeah. You need some, you can take them.
I don't know that I'm very low. I'll take a couple,
Take as
because,
many as many as you want. I'll let you know when I'm getting low.
yeah, let me know before you have 5 left. A bit more warning than that. Last time you said, well, I'm out of boards, I need more. It's like, well, it starts a week-long process.
This is the short nub. This is
Okay.
the problematic nub. On the 6K, it's no big deal. It still reaches, but on this one, yeah.
So I don't know why they did different length thermistors, but if we specify, it would be
I
good.
mean, I can reach it, and I'll just use a zip tie to make sure there's no strain on it. Oh, there we go. This will work. This is still connected.
Okay, about the max continuous, you have a 40-volt system. And I would disagree, but that's a lot of amps still. I don't like the 300 amps. I mean, it is what it is.
Holy long.
I think we could go higher. We'll see. This one right here with the greatly reduced losses, might run 15. But then, of course, our limit is still the FETs. So,
Yeah. This so I can see a little bit better. Okay, let's see. Where's a good spot? Yeah, you don't have to be in this
we're basically running the max that the Tier 220 package can handle. Because anything more, we gotta go to a bigger, and then they use a lot more space.
There we go. Topped all nice and neat underneath here.
You do all top.
Yeah, basically. If I need to, I can just plug it in right here. I can't reach. Everybody's probably like, you don't have cover on that outlet.
You need to cover on the inverter. I mean, that's the bigger problem. We got 240 in there. There's that myself once.
Yeah, you did. And what blew up our oven? What else did you do?
Fixed it.
Eventually.
Just need a big conductive glue. You put that membrane pack back together again.
Yeah, I don't like this. This is really loose Loretta's. I don't see if I can stuff it in. I'm trying to get it so it's not right in front of the fan. I think this will be a good spot right here. Because as soon as the fan comes on, the temperature's going to fall
Yeah.
with the thermistor.
Yeah.
So I'm trying not to get it right in front of the fan. I think these windings will block in some of the heat too, so that'll give me a better temperature. Can't see anything. It's a little dark over here.
Zip tying your light strips up. You have
I
thoughts?
have a lot of great light. I've got 2 more of those that are up there, the really bright ones. I
Yeah.
just need to hang them.
Yeah.
They're
And
direct wire,
You have
so
dumpers over here getting in your way, so
Yes.
that does make it difficult. The ceiling's low as it is already.
yep. I'll figure it out eventually. I just got done doing all this new wall stuff not that long ago. It was about a month ago or so, month and a half. 'Cause
Yeah.
the-
It really makes the room look different. I mean, previously it was not defined. Now it's clearly defined. Like, this
Yeah.
is the work
well,
side.
the main reason is because of the wood burner.
You don't like the heat?
Well, it wasn't so much that, there was the smoke problem.
Yeah.
That was a huge problem over here. I was getting so much dust. That's why I have that filter right there. It's not running right now
Oh.
because I don't have the wood burner on. I think that's gonna be good. That's gonna need a minute or two to dry. But without this wall here, it was,
Dust everywhere.
and I was sitting at the computer choking and, oh, just terrible. Oh, this camera's still on.
Well, get a good draft going, you'll be fine.
Yeah, but the wall definitely cut down big time on the smoke coming in here, big time. Oh,
Yeah, Carlos is exactly right.
watching us.
The purpose of that bus bar is the metered shunt. That's the purpose of it. And yes, 12K inverter is not a toy. What do you see?
4 out is good for 200 amps. No.
Well, so it's chassis wiring versus long run wiring and temperature rise and all that stuff. So it depends what you use it for.
I'm wanting this system for my final system. Yayan has a 15 kilowatt. SunGold Power has an 18 kilowatt inverter. They're all 48s.
The question is, do they do that continuously?
Yeah, I don't know.
So I was looking at that. Someone said it was a 15K. There was a 52,000 watt surge. I'm looking at it saying, when I did the math out for the FETs, and they say you do it for 20 seconds. I said, if you got 8 FETs like the pictures I've seen, you're not doing 52,000 watts. It's going to
No
blow the
kidding.
FETs out, guaranteed. Even if they're doing perfectly, they're going to blow out.
No kidding.
So if they're doing poorly, they'll blow out way less than 52,000 watts. Come on. It's just exactly 3 times the rating. It'd be an 18 kilowatt inverter.
That's fun, though.
Yeah,
I wonder who's tested that. What?
No, they haven't.
I've never had that happen before.
Zipped it right in around that stuff.
No,
Oh,
it broke the tab right off. That's why I got some cheap ones
it
apparently.
came from the discount store, huh?
I guess so. It's the same ones that I've ordered on
Yeah.
Amazon for a couple of years now. That's weird. I guess they're all not perfect. We can leave just 2 thermistors on here. We don't have to add a third. This is just for testing. All these dikes. Oh, side cutters.
Yeah, it's personal thing. Yeah, personal preferences.
That's what my dad used to call them. Oops. One more of this, excuse me. Grab this thermistor here so it doesn't fall off. Looking right through this choke.
Make sure it's not a metal zip tie.
Slack there. I like to have just a tad bit of slack. So
Yep.
I can flop around just a little bit.
I like that. Don't cut the wire.
Ah! Start all over.
Okay, I guess when we pop these off the terminal, I'll put the screwdriver away.
Well, we need thermistors on the main board yet.
I put one over here.
Okay.
Screw one down.
What about this side?
This over here. Well, you can get under there. The screw is right under here, straight down through there.
Go ahead and show
I'd
me.
like to see you put
Show
it.
me! What about this on top here?
You can do that.
Yeah, I brought the screws over for it.
I put one of them over here. I kind of want to keep an eye on the high side, but there's no easy way to do that. You can screw on, well, there's no place. Haha.
There's one, do you still have that ratcheting whatever? We go right here in the middle?
That's a bigger screw. I don't think that the,
Well, no, but we can sandwich it in between the.
yeah,
That'll work.
either one of these. Yeah, that actually go on a 2-pin. A 2-pin ring terminal
2-pin ring.
right here.
Oh,
Which that's kind of short, 'cause that goes to the lid. Somebody has an extension here, huh?
we only had to extend the 12 kilowatt hour.
Yeah, we get him the right length. And I don't think we need bazillion thermistors, but I definitely agree we need more than
Yeah. No,
Milwaukee can go higher than that.
no, it's spinning.
Oh, you're
So
bottoming out the
I
hole.
need a
Shorter one.
washer
You need a shorter one.
or washer.
They didn't tap that all the way through. You hit the bottom of it, it's going to strip your hole out. That was too long. Squeeze this down in here.
TJ's mad about something stupid.
Kid problems.
Someday you're gonna be real and say, what are they fighting about? Something stupid. There we go. Okay. That's nice and solid. And it's far away from the fan, so we get better accurate reading.
Yeah.
Yank it.
This right here is going to immediately yank.
Yeah.
Fan's right next to it.
Ooh, cool.
Problem solved.
Okay, let's see. Yes, Sid does know what he is doing. Does. D-O-E-S. Capitals. So he's serious. Have some faith.
Oh, Carlos, 6K more enough. Carlos is catching on.
You know I'm joking.
Oh, sure.
I don't know, you broke half of our oven.
I fixed it, and you have patched the mistake, but that's good to go. How many months have you been without that oven by now?
What's that?
How many months have you been without that oven?
Since early November.
November, yeah.
Yeah.
You have to buy anything, just have to, there's a bad button on the front panel, which you can't buy anymore.
It didn't start happening until
Somebody tried to clean it. It has nothing to do with the inverter. That was a heat.
apparently cleaning mode. We're never gonna use that ever again. I don't care how convenient it is. I'll get a brush and scrub the oven out.
The reason it has to lock the doors, probably goes past 700, 800 degrees in
I'll
there,
bet.
it burns everything off, and that heat got right there and melted your button pad.
As great as that feature is, if it's just gonna burn out the pad after a couple times, forget it.
First time burned it out. So
Yeah, who knows when that, because it's got a sticker on it from a company local, so it's been repaired before.
yeah,
3 horsepower is no issues for a 12 kilowatt inverter.
depends what the surge is. So and what the voltage is, because we've had somebody ask about a 12K inverter, 3 horsepower motor at 24 volts, and that's not going to happen.
I mean, yeah, this,
There's some 2,500 amps, and if that's only good for.
Pensacola's commenting on how we don't have any, basically, PPE on.
Any what?
PPE.
Yeah. Overrated.
Well, we don't have any power to it right now anyway, so it doesn't matter.
Yeah, if we have no power on, stick this handle in it, might just stick it back.
What did you do? Here, is it magnetic? Here.
There it is, right off the other side.
Oh.
Let's get the other end. Roll it out of here. Yes, it is magnetic.
Unlike those ridiculous little screws that are not magnetic that you
Yeah.
found,
You go in
somehow those are the only ones that I always have to really be careful about dropping,
there, and they always fall off.
and they always fall in between the heat sinks or some ridiculous place like that.
So I guess you're saying it's time to hook up the battery and run a little bit of load on.
Yeah. Whoa, this is
Everything's looking good so far. I mean, as far as I know, which analog and especially inductive design is not my strength, as far as I know, we shouldn't be having any issues with current. You want to power it up, Chest, to make sure it runs?
we can if you want to, yeah. I just want to make sure we got everything. So we didn't miss a wire or something else like
We got thermistors on, we have the power button here, we don't have AC at the thermistor.
that. Wait, how many thermistors have we got in here?
We got 4. And I
That's
have,
it?
I have a 5th one right here, kind of dangling around.
Okay, it's not plugged in, so it's gotta go into the.
Yeah, I guess we do have the lid, we can plug that in 1, we're good.
The final bench test.
Just make sure it runs.
So I'll get my blast shield. While you just stand there and look at it like, ooh, sparks, light. Oops, don't want that touching that.
Screw, yeah, that's why you flip it around the other way, it's gonna go between them.
Don't like that.
Put this on the cover, right?
There we go.
I'm gonna hold it in place.
So we add that to the manual. You ready?
Get the top power on.
58 volts.
Power on. It's running. So it works.
About 900 milliamps again.
Yep, those ferrets are buzzing, which they weren't on the other one. But we're running a higher core voltage. Increasing core voltages right now. I can't get my meter probe under there. Where's that bolt?
Which bolt?
He said it's probably inverter up so I can get the meter probe under there. There we go.
The max you can run on a 240 volt motor is 4 kilowatts, which is about 5 horsepower. Anything more than that, you need 3-phase power.
Neat. What is it? I've heard of 10 horsepower 240 volt motors.
3 horsepower is about 2.2 kilowatts. I believe, it could be wrong. 12 kilowatt will handle that no problem. The 6 kilowatt will handle that no problem.
So the 6K is a pretty good surge, but the problem is limited sets. 3 horsepower is 2.2 kilowatts. That's probably synchronous motors. But the 12K will have that no problem with the surge on 48 volts in. So you decrease input voltage, the surge goes down because we got a max limit for FETs. 2.5 horsepower air compressors, a washing machine, 2 2 freezers. Just write your Christmas wish list while you're at it. Okay, I say that's good.
Turn it back on.
Oh, you want to drain it, yeah?
Yeah.
Or we can have it charged up and have a big bang on the breaker, unless you soft start it.
The 400 amp breaker, yeah, I mean it's a little bit loud, but it's not like the 300 was.
I still recommend soft starting it.
Oh,
It's
geez, Sid, listen to you. You're all safety about this one thing.
because it's those big spikes that blow stuff out when you do inductive
As many
slams.
times as I've turned that thing on and off, I've never once did a soft start on it.
Well, do the honors.
All I do is get ear protection and hit it real fast, and then it
Run
doesn't
away.
seem to.
I'm just curious to test with the lid and see what it looks like.
yeah, go ahead.
How much did they mess up on the lid?
I did not put a grill on that hole there. I probably should do that.
Health and safety.
Later. It doesn't have to be right now.
Health and safety.
I'll definitely do that later.
Those wires are plenty too long.
Yeah, well, like I said, it was only because I had to keep removing the lid. I was getting tired of having to disconnect everything. Ooh. Now the lid goes inside, correct, or outside? It's
Inside.
Inside. This side's not inside. So usually I'll push it in and then set it down.
Yeah, but we have these output
Yeah,
wires.
I
and the
can't see
wires
what's going on
there.
on the other side.
Output wires on that side. This side I gotta get past the transformer up here. Some assembly required.
Well, fortunately the customer doesn't have to worry about this. This is what I was
You
doing.
have to get past the fan right here.
It's still
Yeah.
caught in the fan.
Well, right here, the output wires, which will get changed anyway, so move the box outside, and
Okay.
these will be coming straight in instead of coming at this angle.
You alright?
We still have voltage on it. I didn't expect to feel that much.
There's still, oh yeah, the lights are still green.
Lights are still green. It's not oscillating. We should have no AC on it.
I think you're just overly sensitive to that particular spot.
Did I hit it too many times?
I guess so.
Hit this inside, they'll cut it off.
That side over there is on.
Display is completely in the wrong spot. I kind of want to see what the display looks like, but I've got to see tests before we close it. There it goes.
There we go.
Okay. Okay, done to the lid.
Would it look stupid if they cut our logo out in this instead of having a fan
We
grill?
could do that, but it's one of four. I'm thinking, is it really that important?
Not
So
really.
the lid doesn't look too bad, except they cut it, that doesn't line up.
That's why all the screws stripped out when I took them out. Nothing lined
No, the
up.
screw stripped out because they didn't tap the holes. They just smashed the screws in and shredded the threads.
Why is the back folded back a little bit like that? It's like that, yeah.
Because the power button's behind it, and you're smashing it against the transformer.
Oh.
So the lid is not bad here. If only had screwdrivers around here, I could actually do things.
Yeah, Sid. Grab your screwdrivers. What are you bringing? Okay, 6 kilowatt can run 3 horsepower. Randy runs a 7 horsepower planer molder.
With what?
240 volts all the time. I don't know what inverter he's talking about. Which inverter he has me? 6 to 12. This gentleman has a 15,000 watt power jack, 48 volt, and has a hard time starting my 2.5 horsepower car lift.
Yeah, it's a power jack.
You can run. Problem is finding cheap high horsepower motor that's not 3-phase.
Because I've seen motors up to 10 horses at 240 volt. Not that I recommend it, but they make them. Okay, so there's a problem there.
What?
Just a bending issue. We got a big gap right there.
Sounds like to me we're gonna have to order another case, not a transformer, but a case.
Well, transformer too. Well, there's that power button don't fit there. We got a big transformer wire right there. Yeah, another case thing is if I change the cord back to the other one with the new spec on it.
Let's go through all this all over again.
And they did these oval out, which makes it not work. Now that didn't sound good.
Well, that was glass breaking for sure.
Yes, those holes need to be moved up on this side. They all the way on the bottom edge and for no purpose at all. These are cut out from the bottom. And that right there lines up. So yeah,
Make sure.
width wrong, that's wrong too. There it is.
That was the oven breaking again. So.
Uh-huh. I'm very convinced.
That's the heating a little bit that she's sweeping up. How big of a battery pack do I need to run my 48 volt 6 kilowatt inverter for 24 hours?
What's your load?
Yeah. If it was at 6 kilowatts.
See, if you're running no load, you can run that with a small battery for 24 hours.
Yeah, that's what Pensacola says. Depends on your load.
Yeah, there's open-ended questions that you can't answer. You need more information. There's more variables. They ask how many long tractor batteries it's going to take to do that. We'll say, get a power jack.
Can you run multiple power jacks in parallel mode?
Yeah, you can get parallel to smoke.
So at least for a short time you can.
Yeah, measured like 8 milliseconds. Half an AC wave.
What are you gonna do about the power button?
That's where I'm saying we may have to move the whole thing.
Okay, if we have to, we can just leave the power button kind of hanging
The
out.
problem
that's
is
what I
these
did.
right here, which we can bend those down and around, but right there's a power button. So I don't want to off-center it, but there's a big old hole of open space right here that's perfect for displaying power button. This right here is being difficult. This is perfect. So I don't want to do that, but it might be the best course of action. Not symmetrical then, but if it works.
A while ago, some people were asking why we didn't put the power button on the front with all the connectors, and I had made the point that reaching over there
Yeah.
with high voltage isn't exactly the best idea, but
I've zapped myself reaching on for the power jack power switch. I don't want to
Yeah.
do that. We put it right here. It's right next to the
games put their power button at. They put it at the top.
It's on the top, yeah.
Yeah,
It's always on the top next to the display. I like things to be symmetrical and centered and everything.
Me
but
too. But
That's not gonna work right there.
it's off a little bit. There's nothing we can do about it unless you raise the lid even more.
I wanna reduce the height of the lid.
Yeah.
It's 15 millimeters taller than it should be. And this mess already, so I don't know. If I reduce the height of it, I might be able to put it straight centered over the control board. But that relay is gonna be the bugaboo, because it's pretty tall. It'd be way better if the Wi-Fi board was right on top of the control board instead of on top of the transformer. Well, wanna move it over?
Yeah, we can.
Next step. Double battery cables, we don't have anything on the positive side.
Not yet. The cables are over here.
You got all your cell on balance, it looks like.
Are they now?
That was still tripped, 4.15, so these are still not let go. Still at 25.
Shouldn't be charging, otherwise we'd be hearing.
Well, one was tripped, it's gonna stay tripped.
Well, it won't stay tripped for very much longer.
This is doing 0.3 amps, so yeah, it makes my boost too high again. It's not being stable. Need that screw in there. What's that?
Got it okay? You need help?
Yeah, just making sure I get. Yeah, that thing weighs a little bit.
Up and over.
Definitely not something I want to put on a wall.
Yeah.
What?
Quite shape there.
Design a wall now.
Okay, so hold on a second. We gotta figure out. The transformer has to be on the left. Because these won't reach if it's all the way in the front.
What wall?
These. From the
Okay, so
from
it's
the breaker
sideways.
panel.
Be short for your battery wires then.
Yeah. I mean, that's the way I had it before. That's how I. Yeah. Okay. Watch your fingers. Here it goes. That shouldn't be.
Yeah, a little sturdier rack.
Well, I mean, I didn't
Expect it to last this long?
well, that having a heavy, this did just have a 6 kilowatt inverter on it. That's all it had on it.
Been missing this for long?
Oh yeah, hey, that's where that went.
This looks a lot better than the previous prototype. I mean, the wires all kind of in more control instead of looking like a bad hair day.
Yeah, it does.
Looks a lot better.
So,
A lot harder to get the MOSFETs in there,
we want
but
to skip the fans for now and just do some load testing, see how the FETs look before we add cooling or anything.
all I want to see is how the FETs look at put loads on it, and if as long as the FET drive stays good, fine. And it's up to you to do testing past that, and I can head on my way,
Yeah, that's fine.
get the new FETs working right.
So, what was the size of that?
Got the camera facing the wall, or you turned it off?
No, it's still running. We'll get to it over here in a second.
Over where the window is at?
Yeah. Yeah, I guess if you wanna, while we're hooking all this up. So, the 2 battery cables that I did have, what did I say?
We got legs down here, which is a little short.
They should reach over there, I hope.
Breaker's off. Yep, negative.
Breaker is off, yeah. That's your negative battery right there.
Yeah, there's no fuse on this.
Nope. It's kind of nice to be able to use those for once now.
That's the intention on the other one the whole time, but I guess we used two's kind of won over.
Now, gonna have to cut these. Forgot. There are terminals that I used to use
Yeah.
directly to the board, so, wait a minute, this is input. Make sure we get these right. Neutral.
Socket on that's proper, this wrench is not the right thing. What size is it?
Is it 13, I think? It's 13.
We got a 17 here.
Should be a 13 sitting there.
It's gotta be bigger than that. 13 right here, but yours, the
What?
screws are bigger than that, aren't they?
Yeah, that's a 15 for this one.
This is 17.
Is it really 17? Is that big?
Definitely not a 13.
Where did... I wonder if I dropped my 17. What is that?
17?
Okay, yeah, I got a ratchet for this.
Oh. I thought you were out of those tools. You don't have hand tools.
Some things I have kept down here that the kids have not wandered off of.
Left hand monkey wrenches, I assume?
I guess so.
Pretty tight. I mean, if you want to snug it down tighter, you can. Got the caps we put over them. Make it look like we actually are getting somewhere. Except this right here is only going to a single string. We got 2 wires in there, so it's too big. Cap won't fit on. Well, they're plenty tight, all right. Yeah, they won't fit on right with double wires on. Don't need that much anyway.
This is not, this is off right now. Right?
Upside down, you sure? You say it's off, it's facing up.
Check it with a meter.
Yeah, trip, see the way it goes.
Okay, it's
Yeah, 13 for that.
13.
That's not a 13.
14.
It's a 14.
Who the? What did I used? Put all my. I had a socket on here because I just took it apart here a couple days ago.
This right here, that's way smaller.
What did you say it was?
Another one right here, that'd be a 14. You got the other cable?
Here's a 14. Okay, you got the small. Oh, right here. These don't thread though. I could not find another one of those bolts that actually threaded with. You turn the camera around so not everybody's watching us.
Isn't that what the live stream's for?
Yeah, no. Let's see who's talking what. What a mess. Sid is the one who moved the camera. Somebody blaming Sid for moving the camera? Is that Sid? My first time catching him on video? Good to see you, bro.
Says who?
Civil Repair.
Oh.
You know who that is?
Nope.
Cool.
Oh, Windows went blue. That's lovely.
Ah! Blue screen of death.
Where's the other bolt for the this terminal here?
I don't know.
Black one. It's missing in action. We never had. No, we've had it. Where is it?
We had to. I didn't take the battery cables off, so I don't know.
Is this your 14? Yes, it is.
Okay, so we found the
There's
14.
your 14.
I didn't take the battery cables off. I don't know where you.
The one was threaded. The other one was I had on the whole time.
Well, this is a joke.
I set it down somewhere. There's no place for me to set stuff down.
Okay, here's a
There.
new one. Yeah, I can look for it later.
Where will it go to?
I don't know.
It's right here.
Jeez. Okay. Is this one tight?
Finger tight.
I don't like that. What size is that? I think that's a 10. Or 13.
These are definitely designed for just a single 2-aught wire. Now. Doubles don't work in the housing.
It's a 12. What a weird.
This around. And not drop it on the balancers, they wouldn't like it.
Yeah, please don't do stuff like that, please.
Makes your day more exciting. Okay, there's 17. Wiggled around. Oh, loose enough. Yours are tight. Where's the 17 for that?
I don't know where to put it.
I didn't use it. There's 19 there.
I thought you were just using it.
I was, but you got the ratchet now.
It's in my hand.
So you got the 17?
Yeah, it's in my
Okay.
hand. That's where you left it.
Okay, fair enough.
How's this video look anyways?
Oh, stripping out those things, or is it not?
Alright.
Yes, what? Yes, threads.
The threads are stripped out.
Well, no, on the this wrench on my hand, is that a wrench? It's the plastic ones without nuts on them. That's what's explaining if the stuff's too big. Then you
Uh,
need the frame.
John wants to know what a 6 kilowatt power jack converter is capable of. Maybe 2.5?
If you're lucky, you're half these days.
2.5, I think.
If you're lucky, it used to be, but now they're using ASL ones in there. Now, BSOD is Windows' most popular feature. First introduced in 95, here are 2022, and they still haven't removed the feature. Fair enough.
This here is input. This here is output. Okay. Crap out of this.
Inverter's off, what you worried about?
I'm over here touching all these AC lines, trying to.
Okay, and we have probe one. I only want to keep an eye on one side because they're pretty matched. This one goes on negative. And I gotta get all the way in there for the gate. This is lovely fun. Gate is right there.
I need a blade for that. Well, I don't have to reach into the control board anymore.
Because
These, well, that's what I was having to do. I was having to go this way and
Yeah.
then around to try to get these in here, but now I can use the terminals. Isn't that fancy?
I put the terminals on the first one, someone just bypassed them.
Yeah.
I didn't find that other terminal because on the chassis I'm taking back, the terminal's missing. Been removed from that one. Where is it? And all the wires went with it too.
Here.
Over there? That's the one from the other.
That's
Okay.
the one.
That's the 80, not the 60s.
Yep.
Okay? This screw just backed out. That goes on this chassis.
This is L2.
screwdriver in there. Those long screws. I'm missing a screw on it. How about that? Where's the missing screw?
Is there a missing one?
Yeah.
Who knows? Fell out somewhere. I don't know if it's been missing the whole time or.
Yeah, it wouldn't have been. It was fully wired up and we got it.
Are they different size than the 6 kilowatt ones?
Yep, bigger terminal.
Great.
That one fits. Long enough? Yeah, that'll do. Wrong side, but it fits.
Oh, that's cool.
Oh, there's 2 missing screws. What you doing here?
Jeez,
They're way too big. Those are too long. The shorter one is that big old thread.
Okay. L. Did you want the L's matched?
What do you mean?
Like L1 out, L1 in?
They should be.
Okay.
Otherwise, you might get in trouble.
To cross. You have a regular Phillips screwdriver?
Hey, where's yours?
That wasn't what I asked. Okay, so we're gonna need that for the bar. Well, here, if you wanna start doing that, I gotta cut this neutral up anyway. This, so this here is L1 out.
Out as in inverter out.
Inverter out, L1.
Try to squeeze this thing on there, it's too big.
Inverter out, L1. I guess it wasn't made for that.
Yeah, so it's angles.
Whoops.
Okay. L1.
Will that fit in 4 AWG though?
It'll fit 4 on
0 4, yeah.
Or the single will be just fine. This L1 is on top.
Sure. This is definitely where PPE is required.
Yeah, these things can be nasty if you do stuff.
This is panel out.
PPE like
Neutral.
a light maybe.
Oh, I know. I
Back
really
right here.
badly need to get a light over here. And what does it do with the?
Yeah, you left the screw on this already? Yeah, you did. Right down
How?
there.
How's that possible?
Down near the balancers.
Oh, jeez. What?
Try to unscrew it. I
You
thought
moved it over here.
I haven't loosened any of these like that.
That's
It's
weird.
out.
Those things, PowerJack doesn't tighten them at all. They just stick them in there.
Yeah.
I tighten them down every time I open one up. Oh. Oh, jeez.
L1.
Okay, this is L2.
Okay. This is an 80 amp terminal block, so it's not going to handle 100 amps continuous. And the wire won't fit wires big enough. These wires are about the max it will take. Where
This
these
is 6.
6 gauge, that's about the max it will take. And I have not yet found a bigger terminal block yet that I like.
No.
This is actually the same manufacturer as the other ones. They said, we try a mold for 80 amp, not many sell.
Oh.
So it was just, we have a few pieces of stock, you want to try it? It's like, yeah, it does. You got the mold, make some more.
Need some electrical tape on that. Neutral is running the panel. Just hanging there.
Crunchy sound.
Crunchy sound. Cinnamon Toast Crunch. Those are neutral. Neutral out. For those of you who are just joining us, we are getting ready for the first time to put the inverter on the house. Let's see who's all commented on what.
6 gauge.
First rule of solar, decrease your energy needs or get rid of all your kids.
One's easier than the other.
The dollar amount, the batteries won't be worth it. 4,000 amp hours seems right to me at 48 volts. Good off-grid system. Your brother says, at old man on the corner at 48 volts, they'll come out to needing 4,000 amp hours worth of batteries. Oh, he's talking to that other guy. Blue screen of death on Windows, the most popular feature introduced back in Windows 95. Blue screen adds festiveness to the operating system. All right, Sid.
Oh, splitting the terminal in half?
Did you what? What
I
happened?
can't see anything in here. I'm trying to.
Okay, let me get you a light. Oh, jeez, Pete.
I know it's ceramic. I know that's brittle. But these should be much sturdier than those wimpy white
Yeah, I think so.
wiggly things. They can crack. Freaking threads out.
You're kidding.
I don't know. It sounded really weird. Pull it out and see what we're looking at. Oh, it just drove all the way straight through. I don't want these strand bolted. What do we place it on? What was what?
I don't know. They were complaining about something. They yelled my name and they complained about something. We haven't turned the power off yet.
Huh.
TV went out. Wham! Wham! The TV's gone out. Wham! We don't have power. Wham! The internet's gone out. Wham!
Live without.
Wham!
Yeah, seriously. We got all this property that we were hoping that they would go out and frolic. No, they just stay inside and watch TV. I mean, once in a while I like sitting down and watching a movie or something like right before bed, but I couldn't stand the TV all day long. Even when I was a kid, I couldn't. I wanted to be doing stuff. I wanted to be active, motion, moving. Maybe I'm, what do you call that? ADHD or something?
There's nothing
Sid's
valuable
life.
on TV in the first place these days.
Yeah, no. Sid's wife will like that. I don't know what he's referring to. Yes, it's very cold outside right now. It's gonna get cold this weekend down to 5 degrees. And it's nothing like Russia or something, or Siberia, but it's cold for us.
It's holding in there.
Are they? Good.
Not certain what's going on with the terminal though. It's flattened out. Okay. This is going right through the wires.
Is it? Those thick wires, it's going right through them?
See? It's bottoming the terminal out. It's going right, twisting right through them. Not sure I like that. Okay, well,
Hold on. Make sure the power button's off.
It is. That's yours.
You want to do the other side?
We need power for the scope.
Oh. I'll just get another extension cord here.
Got your backup, I hope.
Yes, I can plug it into the backup if you want. Are you expecting a light show?
No.
Me either. Unless that transformer significantly alters the behavior of the MOSFETs. Okay. Cool.
Make sure no one's running the oven or anything like that.
You've already got the oscilloscope set up?
Turn it on. It's around, so.
On battery. This side of the panel, though, is not, nothing's gonna go off in the basement.
Okay.
That panel's all the upstairs. The left panel's the one that's downstairs.
Don't like the house.
So none of this stuff's gonna shut off if the inverter goes off. The big moment. Let's see. The big moment is coming, you guys.
You make me nervous after all the challenges we've had.
I know. This is our big moment. Let me get a little bit closer here.
I mean, it's worked perfectly on the other one. You've been using it half last year. We changed things. Okay. It's currently 2 o'clock. What do we have for a soft start?
Nothing.
Use a heater, a proper heater like this right here. Let's do a soft start.
You really, really want to. Oh, you're talking about the load?
No. It's right here. Turn it on, 1500 watt. DC resistance soft start.
What?
Instead of going bam. Come on, Sean.
As many times as I've done that,
Mm-hmm. Hold up to here on this side. I can reach the bottom side. No, I can't. The wire's too short.
need a longer wire.
Yeah, I can't reach around the mounting. A little longer. Definitely wire this heavy. Hey, it said we can do 1250 watt. Still 15 amp limit. But we'll do it wrong. We'll get a big
Well, this is
watt.
gonna be fun.
This will be fun. It's here. Looks like someone's coming down. Power button fall down. Okay, positive there, through the heater. Pop. Lights are lit. No bang.
That was anticlimactic.
That's what I was aiming for. You want to hit the shotgun bang. So, heater broken on the heater. Unfortunately, you have to throw the house on it because now we're set.
Yes, there's no way around that right now.
Okay, breaker is.
It's not even running.
I know it's
The
not.
inverter's not running.
Breaker is
No, the
off.
inverter's not on. The breakers aren't switched.
Okay, power on. It's just regular behavior on. Yep.
Is it running?
Mhm.
Okay, I'll go warn everybody the house is about to go off. Hold on a second. dude. Cut the main.
You've done many times. Do it again. You got the earplugs.
Oh, jeez. Oh, there's a chicken up there, ready to watch the fireworks. Ready?
Yeah, the waveforms look good.
There we go. House off.
Mm-hmm.
House on. Running for the hills.
Okay, I'm coming in. There's a bang instant. That's the one I'm concerned about. Everything else is fine. We got the kick there, and the spike is at 2 volts. That's fine.
What's the load on it right now?
670 watts.
Oh, pfft.
So I guess for the viewers, here's what I mean by that Miller kick. Right there. This right here is the switching drive, and that right there is the problem. That is the other FET switching on. And off.
But it only goes so high, and then it doesn't seem to get worse.
With these FETs,
Yes.
the FETs with the M suffix, that went right through and toasted them out. If that turns on, it's going to dish or across the battery, the FETs, and they go toast. So you want to pop on some loads like a space heater or two?
Yeah, we
Just
can
pop
do
in
that.
3Ks. Just a moment. Throw my USB drive
We'll
away.
have to go upstairs to do it.
Do you have anything down here?
Well, no, the basement is all on the second panel.
Oh, you changed it.
Yes.
Okay. Used to be our test right down here.
Well, it was pointless to have some of the house up there on the second panel. It wasn't saving us any money.
Yeah. Oh, right. I get it. Okay, thumb drive is in. This is, of course, there's the power button again. It'll scare us like that.
What? She's gonna hit the microwave. Is that okay?
Danielle?
Yeah.
Should be fine. How about we hit the space heater first, and the microwave should be good. I think we're good. It's run fine before. I just want to make sure.
All right. Plug in a space heater.
Spike there is full. That's 1500.
1500.
Okay, turn it off. She can run the microwave.
It's on. It's on high.
Turn it off. She can run the microwave.
Space heater's off. Microwave is going on. Microwave is on.
I hear the throb of the microwave transformer. I mean, still, we're a 4-volt spike, which is the threshold of 5, 4 or 5.
Ready to start central air?
Ha, I'll let you do that. I mean, I'm not. Hey, can you kick the space heater on while the micro's going? Space heater on while the micro's running.
Okay. It's on.
Yeah, it actually went down.
It went down?
Yeah, the spike went down a little bit. Yeah.
You want like the stove top on, the oven, and anything else like that?
So that's where we could start with that. Yeah, I can't see the display. This is the part that's killing me. We're at 3.3 kilowatts. You can pop let's start from the ground again, though.
What?
Turn the space heater off. And the oven is 6Ks, you said?
The oven is 4.5.
4.5. So turn the space heater off and kick an oven on.
Okay. Oven is going on. I gotta figure out which button's which.
Ah, no muscle memory?
Yeah.
Touche.
Oven is on.
Yeah, no concerns. The spike is staying the same. That's what I saw last time. 4.3 kilowatts.
Okay, so that's about right.
Yeah, pop the space heater. It'll take us to 5 or 6.
Okay, space heater's going on. Oh, go ahead. Hurry. We're gonna turn the microwave on instead.
Okay, right ahead.
Microwave's on.
No change at all to the splash.
So it's getting better as the load goes up? is that
Well,
what
not
you're saying?
necessarily. Pop the space heater on.
Okay, space heater's going on. That's the space heater.
We're at 6.5 kilowatts, and I see no reason for concern whatsoever. Okay, well, we're at 6 kilowatts. I forgot
Do you
something.
want to hit the stove top, add another 4 kilowatts or so?
Just a moment. Battery amps. Okay.
What?
I'm going to have to work on that.
Okay, what's wrong?
Transformer's buzzing pretty good. The battery current sense is not reading.
Not reading at all?
It's not doesn't have a waveform. So if I go to the diagnostic, it probably won't be reading anything useful there either. Battery amps 540. Turn the space heater off.
Space heater's going off. Microwave's still on, so's the oven.
Turn the oven off.
Oven is going off. Everything's off.
Okay.
And I heard the hot water heater kick on, so
Yeah, I
that's
did
running
too.
right now.
Okay, so I don't think we need to do any further testing. It appears to be working beautifully like it was back when we tested the start of the A and everything. The only issue I have right now, I can store it back home.
Okay.
The problem I'm seeing is the bus bar, obviously. Remember, we had all that used 2 wire, was our current sense.
Yeah.
And it had much more resistance than a gigantic, thick, 3 millimeter thick by 20 millimeter copper bus bar. So when we're running loads on it, because these spikes are just staying right there, I have no concerns
What's the
whatsoever.
temperature?
No, we barely got anything warm.
Well, we
The
got.
transformer's gently
We have
warm.
thermistors on there now, so you can see what they are.
Highest one is 96 on the
Okay, that's not
transformer.
bad. It wasn't running that long, but I was just curious.
96 on the transformer. I mean, it feels gently warm. So, my only problem is I'm not seeing any. I'm supposed to be seeing the oscilloscope waveform on the current in that bar. I'm not.
So why?
Because the
What?
resistance is so low.
Oh.
We're using that used to, which has so much resistance, we could see voltage drop across that all day
You
long.
know, I'm really surprised they used to is it's pretty thick wire.
Well, what was it, 8 gauge?
Yeah, but we had so many strands of it.
Yeah. So,
I was surprised the resistance was a lot higher. That's surprising.
I will say for the
I'm not
purpose.
saying you're wrong, but I mean, that's a big hunk of wire right there. I'm surprised it was so.
Why don't I take it?
Yeah, go ahead.
For characterization purposes.
Absolutely.
Because what's the gauge on it?
It should be 6 or 8.
Because I'll just do mathematics on that and figure out what it is. So, I will say it's anticlimactic. You know, start the here, start this, do everything else on the other. It's all great. I'm saying you're good to run. You can hook the AC input up, get the AC input calibrated, go back to your ATS pass-through switching. You will need to set your current limit settings and stuff like that. But this spike right here
Mhm.
is highest at no load. Or a moderate load, so up to 1500 watts, and then it just goes down.
Sounds
So-
like it's like working harder at lower loads than it is.
I don't know, because if this is Miller capacitance, is simply when the drain, we get technical over the camera, when the drain gets yanked,
Mhm.
it's a capacitive coupling, so it yanks the gate momentarily. So the drain stays high, it goes a little spike. Then it comes down, it crashes there. You can see the positive, negative right there.
Mm.
And so I don't know why it's affecting by load. That doesn't make any sense unless it could be this right here. It could be we're outdoing our chokes, because once we outdo the
Outdoing.
so, or the chokes at no load, they get hot. If you
Right.
load on, they cool down. So it could have to do with these right here being faster or slower slew rate, which is changing the height of the millet. That's probably what's going on. But I see no issues with that whatsoever. Go right ahead, wire up the rest of the way proper.
Yeah.
And-
the fans, the input, all that
The
stuff.
fans on it, AC input, and the AC thing there crossed, and I can go home and make Tiffany happy. But the trip was well worth it. I got lots of information, lots of data. I have data's on that transformer, data's on the old ones, the new ones. I know to change, I know to work on, and
Did you hear that, Tiffany? He's staying for the whole weekend. In celebration.
the whole weekend is just part of it's over.
Actually, this is
Saturday.
we wasted more time just correcting.
Yeah.
The crap that they did.
Well, I expected that. I expected that.
Should have just had him send it to you, and then you could have figured it all out, brought it up.
Yeah, but
Oh well.
we did what we did.
Yeah.
Well,
I mean,
for the
it's
rest
working.
point,
What?
check your efficiency.
Oh.
Duh. Where's your meter?
Should be on the desk over there.
Because I know mine's not accurate. Where is it?
We're only at 1270 watts.
Still, but we could pop the oven on.
Oh, sorry. I put it underneath there.
We can pop the oven on and get numbers, because that's a steady 6 kilo or
Yeah, if you want me
4.5
to.
kilowatts. I just want to figure your meter out.
Go all the way up to 40. Well, might have to be 400 amps. I'm not sure how many.
I have a 400. Where's the DC button?
Hit the orange button once.
Cell? Okay.
Yep, and
It's 0.
zero it.
Now I got a problem. I guess I'm glad I got yours. You got 2 wires here. So we're running 33 amps, 33.7 amps at 57.5. I gotta get a voltmeter on that because I know the inverter's not quite accurate, non-calibrated. It's weird. I use the exact same parts, put them in a different place on the board, and they read differently. I mean, what else should I say? So, current sense needs some attention. Yeah. whatever the battery.
Well, I won't hit it with the air conditioner anytime soon.
Yeah, I guess.
Now,
that
as
is
far as the
concern.
continuous loads are concerned, that's fine. We can go up to 12 kilowatts. You're not concerned about
Correct.
blown. Okay.
Correct.
It's
the big-
just that big surge. Okay. The only thing that's going to do that is going to be the 4-ton air unit, so I think we're safe for now.
Yeah. So
I'm not going to be hitting that at all this winter.
So hopefully I get this sorted out. I need to get it sorted out before I can do production runs. So I
Yeah.
mean, I gotta get it sorted out ASAP. I don't want to thin that wire down because you know about Chinese amps. They're
Yeah.
a little bit lower than US amps. And the Chinese were saying about this bus bar, yes, 600 amp is okay. If I try a little smaller, no, that is too many amp. So
We want to see temperature at load, see what this transformer will do. I can't do that until we get fans on it.
578, so 57.8 volts for the record. And we're running 33.7 amps out. I calibrated the output. It says we're doing 1317 watts.
Do you want me to hit the stove to get a bigger number on it? The oven, I mean.
Not quite right
Okay.
now. Let me just run a quick calculator.
It doesn't seem like it would be as efficient as at lower loads than it
Correct.
would be at higher loads.
Well, the higher loads, normally the higher efficiency, so, I gotta do the math here. Divided by, parentheses, 57.8 times 33.2 equals a very lousy 67%.
That is lousy.
That is very lousy. Assuming this is reading right. It's 1300 watts out for 33 amps in. That,
Well, check it with the AC out.
what's else? I get this right here to see
Yeah.
what the out is. So it's saying we have our percent, so we have more, so I know what we're doing.
That's abysmal. Unless
Well-
it gets really, really good when it hits some kind of stride.
So here's the thing: if this transformer core is being that saturated out, I mean, I don't know. It is what it. We'll gotta figure out what it is. Amps. So it says running 5.5 amps, so we should have 10 on one of these. 9 on that one, and 2.3. Actually, I can cross these here and get it to read right. We got enough wire, and I don't pull it out, and make it go bang. My specialty, right?
Yeah.
I got on there backwards. Come on. Okay, 12.8. So we should be seeing about 6 registered here, 5.5. So that's going to mess the efficiency up big time. If I run the math on it now, let's do math by math. I know we're doing 240, it should be. Come on,
Brother
calculate.
says that's 70% efficient.
This is all messed up. Let's redo the math entirely.
Yeah, that doesn't seem right.
240 times, that's at 120, I measured 120 amps, because this is on 120 times 12.59 divided by, and we're at 57, 2.82 times 32 to 33 is 79.80. So yeah,
That's the charge
we're
controller.
having, this is the current, most likely the waveform, here's what the waveform shows on the
Speaking
scope
of,
here.
excuse me, I should probably turn that on.
Ooh,
What?
that's gonna make it not read right.
What is that?
That's not a sine wave. See that on the live stream? That's not a sine wave. No wonder the meters don't agree. That's the load. Whatever's running that 10 amps is very not straight. That doesn't agree.
Wait, I'm confused. There's no pure sine wave coming out of the inverter?
No, that's the load.
Oh, that's the load.
So here's sine output. Beautiful
Okay,
sine.
okay, perfect.
So that's input load, then we have transformer current, which will be the same as output current. Input current squared
Looks like
zero.
a triangle.
It is.
So what's
Whatever's pulling 10 amps was doing a terrible job of doing a pure sine. So that's why this doesn't match with that, and why our efficiency looks terrible. So we're getting 80%. That's not great.
wow? The sun is really starting to come out now. This is the perfect time to do a big old load test. Batteries are still full.
Okay, 57.8. So we're still 57.8. So if we want to do a higher load thing, you can pop the oven on.
What's our temperatures at?
That is a good thing to keep in mind. 101, 110 on the transformer.
Oh, that's not bad.
110. I mean,
Yeah, I can turn the oven on and see.
Yeah.
No?
power save on.
Oh.
Decided to give up the
Make sure you zero it
goes
out.
Okay. Yeah, pop the oven on. I'll rerun the math on this one.
Sounds good. Oven's going on.
101 amps. 101. 5782 still. We're at 39.4. 81%. That's still terrible. We're on 4.3 kilowatts. Output amps, that's a bit rounder, a lot better.
Yeah.
That's 81%.
Still, that's not very good. What's going on? Why is the old one doing better than the new one?
Well, I just calculated numbers you took. I didn't actually quantify it myself. So I got 3 meters telling me exactly what's going on. So you pop the oven off. We can rerun this stuff later. But why is it at 81.5? It should be past 90. Okay, well that's about all I got time for now.
What's that?
About all I got time for now. I should head on.
Yeah, that's
start
fine.
packing up. It is running. We have the new transformer in. You get the fans on it. Figure that stuff out. See what it does with loads. That's all I can say.
Hit it with 12 kilowatts. Not right now.
Not
We'll
right
do
now.
that after we get fans going.
They got the fans on it. Hey, Carlos, we get solar panels at 80% efficiency at 1524. Oh yes, that makes a huge difference. We need a quarter the size.
Shutting it down for now so I can get everything.
We definitely got warmth. So this is where, yeah, we got warmth up the transformer.
Well, that's expected when it's running the oven and stuff.
There's only 100 amps though on the AC, so or the DC was 101 amps registered.
Carlos says, time to go home, Sid.
Point taken, I know. He says every time up here, we're always here longer than I expected, and she's right. Except this time.
Except for this time.
Yeah. Work is done.
Work is done.
Well, as far as I can, there's more work I gotta do. I gotta get the fence to stop doing weird stuff on the new board with the new type of FETs. I know that these FETs will work in that configuration because they are right now, very nicely. But if China can't get a hold of them anymore, it's a Chinese manufacturer, NCE Power. It's not U.S. manufacturer. So if they can't get a hold of them, we gotta solve the issue. But I think I have the solution worked on the other board. Like I said, I had them go poof on my bench at 3Ks. So I know this right here is 1500, where it reaches the peak of trouble. So I think we're good. Yeah, she was. I said I'd leave between 2 and 3 was my goal. So you're home around 6.
There you go.
6
So
or 7
still within
p.m.
your goal. So I think what we'll do is we'll cut the live stream off now.
Okay.
Successful trip.
Successful test. I got tests and answers on a lot of things. That is very helpful.
We do need to work on that efficiency thing and find out what's going on with that.
Yeah. If anyone has clues about, what I read, most of the transformer efficiency is the wire on it. The core is purely magnetic. So, yeah.
We'll
We're not
definitely
going to
work
start
on
the
that.
big AC unit because we don't have a current limit. So I got to recalibrate that. Okie dokie.
All right, so go ahead and say goodbye, Sid. Everybody who has been watching.
There.
I know.
Reality.
Your brother's disappointed that we
Yeah.
didn't hit it with 12 kilowatts. I will hit it with 12 kilowatts, trust me, but I'm not going to do it without fans.
We have no fans on. We can't do a long-term thing.
Yeah,
So.
so it's it'll happen, just not right now. There's some sun out there, so now would be a good time, but
So
I gotta
that's-
get everything together.
Do you have a second plant meter? Or just that one?
Just the one.
Okay.
I gave you that, brother.
You did.
What do you want? Give me another one?
I sent it to somebody else. We didn't have one.
Well, anyways, so we're gonna go ahead and cut this live stream off. Everybody say goodbye to Sid and thank him for coming up. We still have some work to do, but we're very, very close now. A lot closer than what we were.
A lot close. Well, we hope. We'll find out. More testing to be done.
Sid's gonna be doing some more testing, so yeah, I think that's pretty much about it, right? So
Yep.
everybody say goodbye to Sid. Thank him for the trip. He's gonna start cleaning up. I'm gonna help him. We're gonna carry everything out. He's gonna head on out because he still has things to do at home.
Got the.
So All right, sounds good. Everybody says bye, Sid.